So the part 1 of the syllabus, we are going to cover about 4/3 of the syllabus, uh, software engineering. Okay, so this is going to be quick, not full, quick revision on your subject. So we are going to start with nature of software, then we will move on to software engineering and the related topics. So we are going to start with software engineering, so nature of software, because you know that our subject is software engineering, right? Software engineering. So first we are going to understand this part, software, then we are going to understand this part, then of course we are going to understand the combination of this, what are the concepts related to software engineering. So that is our plan. Okay, right. So let's move on to this part first. We are going to understand the software, because that is what the software engineers are working with, right? If software engineers are working with software, they must have very good understanding about the software, not just awareness. That is, their serious work is on software. Just like a doctor is working with humans, so they have to understand about humans, right? Their physical things, etc. Similarly, if you are a software engineer, you must be really aware of the concept, things or features related to software. Okay, right. So therefore, first we are going to discuss about software. Okay. Right, so this is the big picture. So when it comes to software, it fits onto the computer system. So we have the hardware, firmware, system software, and the application software. Application and system software together we call the software, right? And of course we have the liveware or the users. So the software engineers involved in developing either system software or application software, right? Of course, the hardware engineers will work on the hardware and firmware, but the software engineers, their interest is developing system software and application software, right? For example, if you are a software engineer in company like Microsoft or maybe Apple, you may be working on some of the system software like Apple, Mac OS, Windows, etc. But if most of the time, what happens in countries like Sri Lanka, most of the software engineers are working on application software. Okay, so that is what we are going to work on if you are a software engineer. So what we are going to discuss is what kind of things software engineers are going to work, and how they are going to do that. Okay. Right, so first let's try to understand the software itself. So the nature of software is it is intangible, right? So that is why we use the term soft. Okay, it is intangible product. Very few number of engineers work with intangible products. Almost all the other engineers in the world work with tangible product. If you take a civil engineer, buildings, right, bridges, etc. If you take a mechanical engineer, different machines. If you take something like chemical engineer, different chemicals. But there are some engineers who work with conceptual things. For example, if you take electrical engineer, they work with electricity, right? So little bit conceptual. Of course, they use physical things like transformers, etc., power plant. Likewise, software engineers, their product is not tangible, right? Not tangible, but it is very useful product, right? And also because it's intangible thing, there is no wear and tear. So once you build your product, you are not going to see any wear and tear in your product. So that is very important thing that you have to understand. Okay, so if a civil engineer build a building, that building is going to be have some corrosions and so many deteriorations, right? Even a power plant, when we keep using the power plant, it's going to be have so many issues and breakdowns. But when it comes to software, where once you build it, it's never going to wear or tear. Okay, so the third thing is software is high demand. There's a high demand for software in the businesses, right? So therefore, when you are building a software, there is lot of expectation from your customer, and lot of expectation if the customer is really serious customer, because he knows that lot of his business is going to rely on this product. Of course, if you are developing a very critical product for them. Okay, so that is very important. So that pressure comes to you if you are a software engineer, right? That expectation becomes sort of a pressure for you also, because when there is a high expectation, when everyone is looking at your final product, you have to work really well, right? You have to give a really good quality product, right? So that's sort of a pressure, right? Of course, it's a good, really nice feeling for you because everyone is looking at your product, but at the same time, it's sort of a little bit of pressure for you also. Okay, right? So because it is intangible product that we are working on, there are a lot of good things and bad things. So one of the bad thing is, right, one of the bad thing is, since you are working on a conceptual product, most of the time requirements are really messy, right? Because when customers explain something conceptual thing, sometimes a lot of ambiguities will be there, right? A lot of ambiguities will be there. Sometimes we can't understand what he's talking about, etc. Okay. Other thing is, it's very difficult to measure the progress. Very difficult to measure the progress. Why? You are working on a conceptual product, right? So others can't see it physically, right? Unless that person is also really experienced person in software development. Of course, that person can understand what percentage of the work is now done, but still it's a very really challenge. So that is one of the place where a lot of conflict between the customer and the development team arises, because customer can't measure the progress, therefore there are some conflicting situations. Okay, so both ways, we can't understand his requirements, customer can't understand whether the product is really in good shape up to now, right? So that is big issue, right? Then another big issue is, because it is intangible, anyone can easily copy your product, right? So once you create your product, especially if the source code is available, it can copy it. Not only if the source code available, if you are given that then the exe or the executable or installation, they can just copy it to someone else, right? So they can give it to someone else. So that is also really big challenge every software development team or every software business is facing. Okay, so the challenge of software piracy. And of course, because it is intangible product, it's a no wear and tear is there. That is another issue that we are facing, right? Because when there is no wear and tear, your customer is not going to come to you again saying that, okay, my software is broken due to some wear and tear, now I need another one, right? So it's never going to happen. Okay, right? So some of those things are really good, some of those things are somewhat challenging for us. So as I told you, software can be easily reproduced, right? Easily reproduced by copying. So I told you the bad thing, right? Some people might pirate you, but the good thing is, once you build your software, you can just copy and sell to another person. Take a copy of it, sell to another person, right? So that is how all these people has become billionaires. So these are the top 10 wealthiest people in the world, right? So out of those, 1 2 3 4 5 from the out of 10, 5 from the IT field, right? 5 from the IT field. Out of those 5, 4 of them are really from the software development field. Only the first person, he is not the software development field, but he is also from the IT field, e-commerce field. Of course, he has to get some software developed to run his business. Okay, so Jeff Bezos, who is the founder of the Amazon. Of course, you know who is Bill Gates. Then the Mark Zuckerberg. Now he owns a lot of things like Facebook, not only Facebook, right? Messenger, Instagram, etc. Larry Ellison, the founder of Oracle, right? Then we have the Larry Page and the Sergey Brin also there. He is not shown here because he is about 11 or 12 place. So they are all software developers, right? So they all are actually software developers, later became entrepreneurs, right? Later became, why they are making a lot of money. They can, once they have their product, it's because it's an intangible thing, they can give it to people and make some money, right? Make some money very easily. So you can see it's good and bad, right? So others can try to pirate you, yes, but at the same time, if you properly do it, you can make a lot of money also. So that is why software engineering fields is a huge multi-million business, right? Multi-million business. Of course, that is why software engineers get a lot of good salary also, because when the business get enough revenue, they can distribute it to their employees as well. Okay, right? So that's something you have to aware, right? So don't think that this is a field that just few millions of dollars. No, this is a multi-billion dollar business. Okay, so just 1 minute. Right. So you must have that mindset. So that is why I told you, forget about exams. Forget about exams. Just concentrate on this interesting field of software engineering. Okay. Right. So how to tackle software piracy? Now, how these people have become millionaires? Because they know how to tackle software piracy. Now you will say, okay, how do you say that Bill Gates knows how to tackle software piracy when I am having Windows operating system, pirated operating system? Of course, you may pirate it, I may pirate it, but still you can see that they have made billions of money, right? So they don't care your piracy, right? Why? They have enough revenue for their money. So that is why Microsoft company is in Sri Lanka, but they don't go after every person. They only go after really big corporate customers, so they have to pay their license fees, right? So that they just ignore you because they have enough money, right? They are generating enough money. Okay, so anyway, they have to tackle those software piracy, especially from the big companies. So that is where they want to generate a lot of revenue, right? So there are few things that you can do. Copyright laws are there, right? So if in case of a big piracy, they can always go for the courts and get their money back, right? So that then they don't sell their product. What they do, they license the product. You never sell the software unless you really forget want to get rid of that software. You just give the license to use it. Still the product is with you, product or the ownership of the product or the code is with you, right? And of course you can go for some innovative business models, right? Innovative business models. That is how companies like Google, WSO2, they are making a lot of money, right? So they don't want to sell their product. Of course they can give the product, most of the time they are in the free and open source field. They give you the product, but they know how to make money in different innovative ways, right? So the likewise, that is how all these people has become the billionaires. They know how to make money out of this intangible product. Okay, right. So now let's see how they have solved some of those problems. Now, as I told you, your physical product might get wear and tear, but your software, if you have bought Windows XP 10 years back, if you have the CD or whatever, still it's fresh Windows XP, right? So in a way, it's good for customer, but in a way, it's not good for a business, right? So how they tackle this? So how they tackle this is, they keep doing some innovations, right? They keep doing some innovations, improvements, so that the customers feel like, no, I don't need XP now, I need at least Windows 10 now, right? So the people who are, they are migrating from XP to the 7 and 8, 10, right? Same thing happened when you operate your mobile phones, right? So if you have your smartphones having something old operating system, like Marshmallow or whatever, now you feel like I need the next one, right? I need the next one. So then you upgrade your phones. When you upgrade your phones, you get the latest operating system. Of course, these phone vendors have contract with the operating system vendors like Google. Then part of your money goes to that operating system vendors. So that is how it works, right? So you can see, though there are no wear and tear, still there are ways to make money, right? There are ways to make money. Especially that is why software field, we want to be very innovative. We want to keep improving our product. Then only there will be constant revenue generation, right? Constant revenue generation. Okay, right. Then so let's look at the failure curve for hardware and software. So when it comes to hardware, initially the failure will be very high. Then initially the failure will be high, then it will be stable, right? It will be stabilized. Then because of the wear and tear, after sometimes it's going to again have a very high failure rate. That is why we have initially low failure rate, because of initially only you are finding some bugs. So that is why when you are buying a washing machine or even a blender, you are getting a warranty period, right? You know that initially there is a possibility of it getting failed, because those mechanical parts, the moment you start operating only, they are going to show their failures, right? So that is high failure rate at the upfront. Then it's getting stable, and again when the wear and tear comes, it's again going to fail. But when it comes to software, there is no wear and tear, so that means this is not going to happen. This is not going to happen. Therefore, ideal software failure rate is something like this. Of course, the initial failure is there, because when a new product is released, right, so there can be some bugs, right, so that failure is there, but afterward it's going to be very stabilized. But reality, so this is the ideal curve. In reality, it's going to be something like this, something like this, like something like this, but in general it's something like this. So why we have this kind of a thing is, usually software we want to keep upgrading. Whenever a new release comes, there's again high failure rate, another release come, high failure rate, and also in general the things are going like this. Why? When you are keep applying some changes, modifications, your software is going to be unstable, because, right, so because you were not expecting those things to be done at the beginning. Now when you are keep modifying, your software is going to be little bit more and more unstable, and also your expectation of the customer is also different. Therefore, it looks, customer feel like it's a failure. So that is how you move on to another version, right? That is how you move on to another version. So that you have to understand, when you are developing software, you have to understand this nature, and tackle that, okay, right. Then the cost of hardware versus software. When it comes to cost component, hardware is getting less and less costly. That means it's getting cheaper and cheaper, right, cheaper and cheaper. But software is getting more and more costlier, right, more and more expensive. The reason is, to develop software we need lot of talented skills. I am not saying that to develop the hardware you don't need such talented, of course you need, but once you build it, once you design it, we can automate it, right? That is what basically the conflict between America and China also. American people, they design it, then they ask Chinese people to build it, right? Because it's all about just operating, and also you can automate. Sometimes you can fully automate the factory. Everything is coming from using robotics and those things. So that is why the cost of hardware is getting less and less, because of the automation. Once you design, you can use cheap labor. But when it comes to software development, still I don't say it's going to be happen to ever. Still, these highly intellectual, smart people we need them to build the software. It is not like manufacturing. We can't automate software development. Therefore, we have to pay them higher and higher salaries, because we need to pick, or we need to attract the best out of the society, best out of the industry. Then we have to pay them higher and higher salary. That is why the cost of software is getting higher and higher, higher and higher. So of course the cost of software is getting higher and higher, while cost of hardware is getting lesser and lesser. Okay, so that is why it's a big multi-million business, right? So a lot of revenues are also there. At the same time, you have to pay high salaries to those people who are involved in software development. Okay, right. So let's look at the type of software. So we have the system software and application software, right? So system software involve operating systems, system utilities, language translators, servers, etc. Application software involve personal software, work group software, enterprise software, etc. So I'm not going to go into details on that. Now we are going to discuss about, remember, still we are trying to understand what this product of software, that is what we are going to work with, right? So if you don't know what is the software and what is the nature of software, you are not going to be a good software engineer, right? Okay, so it's something like, if you are a dentist, first what happens, so they are going to learn about the tooth, right, so that is there, because that you are going to be a dentist. Likewise, unless you understand software, you are not going to be a software engineer. Okay, right. So therefore, don't think that this is waste of time, right? So how do you say that dentist saying that learning about tooth is a waste of time, right? Okay, so let's discuss about the attribute of good software. Now we discuss little bit of how the nature of software, right? Intangible nature, right? The easily because of that it can be easily copied, and a lot of money involved, right? The expectation from the business, right? So let's look at the attributes of good software. So we have two classification in your syllabus: Boehm's classification and Mackel's classification, right? Boehm's classification and Mackel's classification. Let's dig into those two classifications. So Boehm came up with two categories of usefulness: current usefulness and potential usefulness. Current usefulness means basically user's point of view, or end user or customer's point of view. What the customer seeing as usefulness is current usefulness. What the developers see, because developers see few more things than the customer, because they are the guys who are developing it. They see lot of futuristic things, right? So what are the current usefulness, what the customer really expect upfront? Of course, the first thing is effectiveness, or does the work, or the accuracy. Then of course he will be expecting efficiency, economic, reliable, robustness, user friendliness. So those are called current usefulness, right? So then the developer sees so some other usefulness as well. So that is something like maintainability, reusability, testability, verifiability, because they know that in the future when we are doing some changes, when we get some modifications, we need these concepts, we need these features, otherwise we are in trouble. So those are called potential usefulness. So the current usefulness, what the end users see, potential usefulness. Of course, the developers see all these usefulness, but additionally they see some other usefulness also, that is called potential usefulness. So that is the Boehm's classification. When we develop a software, we have to make sure that our software is doing the work, it's efficient, economic, right, blah blah blah. At the same time, you have to make sure that if you are a professional software engineer, right, ඔයාම නිකන් software එක දීලා අත හොද ගන්න මිනිස්සෙක් වගේ unprofessional මිනිස්සෙක් නම් ඕක දැනගන්න ඕනේ නැහැ. Then your task is done. Then you will try to find another customer. So that is the business model in Sri Lanka, right? Sri Lanka business model එක මොකද්ද? කාට හරි වැඩක් කරලා දෙනවා. දැන් මිනිහා එන්නේ නැහැ කියලා දන්නවා. තව customer කෙනෙක් හොයාගෙන marketing කරනවා. තව customer කෙනෙක් හොයාගෙන marketing කරනවා. ආයෙ අත හොද ගන්නවා. So that is not the professional. What the professionals do, they think about the future. They want to care their customers' future, right? So therefore they think about maintainability, reusability, modularity, right? If you are a professional software engineer, whenever you are writing some code, you have to think about those things, right? Because most of the time customer is not aware of those things initially. Of course he is going to get that awareness later, but you must have that awareness when you are building a software. Okay, so otherwise your software is not going to be a really good software. Okay, right? So Mackel's came up with a different classification but highly related classification. So he subdivided into three: product operation features, that is good features which is required when we are operating the software, like the effectiveness, efficiency, user friendliness. Then the product revision features which really going to help when we are doing some modifications, like maintainability, flexibility, testability. And product transition features, that is when we are going to do some transition of platforms, like you want to move from MySQL to Oracle, or you want to move from Windows to Linux. So in that kind of situation, if some of features are good or helpful, so those features also he categorized, like interoperability, portability, reusability, etc. Right? For example, if you have very good interoperability, now if you have integrated it to a payment gateway of a bank, now if you want to change from Sampath Bank to HSBC, that means product transition, right? So that kind of situation, of course, the conceptual interoperability is going to be helpful. If you want to move from Windows operating system to Linux, then the portability is going to be helpful. So likewise, so he came up with three categories, right? That every software engineer must care when it comes to developing software. Okay, right? So common issues of software. Now we must know some issues we are having also as an industry, software development industry, and the businesses. Of course, the software in the engineering software development field is having those issues. Those issues are affecting the client or our businesses, right? So what are those common issues? So the biggest issue is the quality issue, right? So biggest issue is the quality. Lot of software are having lot of bugs, right? Not only your Windows operating system to Android, not only that, but there are ERP systems, right? Some other systems, so they always have a lot of bugs. I'm not saying always have, but there are considerable amount of bugs which really trouble in the businesses. So we want to make sure that in the future our softwares are really high quality, right? Then the cost issue, still cost of software is very high. That is why, for example, you may have bought numerous vehicles, you may have bought very numerous uh, computers, laptop, but you hardly buy software. Of course, one reason is you like to get it free. Other reason is still you feel like, for example, the cost of operating system is too way high, right? So actually they are now making it little bit less and less, right? Because they want to make it lower and lower, right? Cost issue is there. A lot of businesses, they really like to have software, but they can't afford it. For example, if you want to buy a ERP system, it's millions of money. Okay. Then the maintainability issue is there. A lot of software is very hard to maintain, right? Then the interoperability. A lot of software, it's very difficult to operate with some other system, so integrate with some other system. And of course, some systems have a lot of user friendliness issues as well, right? So we want to make sure that not only our product is doing the work, it's of high quality. We can give it at a reasonable cost. It's a highly maintainable, highly interoperable. It's really user friendly, right? So those things are very important for because those are still some issues. So a lot of softwares are not user friendly. A lot of softwares are not interoperable, right? So we want to fix those things, right? Right. Now we discuss about the software. Now we are going to discuss about the nature of software project. Right. So remember, now first we discuss the software. Now we are going to discuss the nature of software project. Right. So that is something like, if you are if you want to be a dentist, you first learn about the tooth. Then we are going to learn about how the dental is going to operate, right? So you know that there are some procedures, right? Likewise, so how the things are now going to work, right? So that is very important, right? So how the software project, or the nature of the software project. Okay, right? So let's see. So developing a software is a complex task. So that is something you have to agree, right? Something you have to agree. If you are not writing a hello world application, you know that even when you are writing a very small program, sometimes you struggle with a lot of compile errors and so many things. Sometimes you can't figure out what is the issue is. Now, when it comes real world software development, it's, of course, it's complex. So that is why we need engineers, right? So that is why they are keep on asking for engineers. So whenever there is a complex things, we need engineers, right? So it's a complex task, and also it's a high expected, or there's a high expectation for this software project, right? So customer is really interested and really expecting lot of from your project, lot of from your product, because he's going to use it for lot of good things, right? Then you need multitude of skills. When it comes software development, you need skills with skill database developers, UI developers, backend developers, sometimes integrators, good testers. Likewise, you need multitude of skills. So it's not like if I take just the previous example, right? So if you are a dentist, you just need you and maybe one nurse or helper to have your dental clinic. But when it comes to software development, either you must have all these skills, or most of the time, that is why we have sometimes 20, 50, 100 of team members. Those people are doing different things. Okay, so need multitude of skills. And also this field is fast evolving, right? Fast evolving. A lot of new technologies are coming, new versions, the technologies are upgraded to next new versions, etc. So that is also the part and parcel of software development project, right? So you have to work with a lot of immature technologies, right? Then, so the need of managing changes. So the moment you start developing your project, your customer is going to come up with a lot of changes, right? So that is the nature. So I am talking about real world customers, not dead customers. Real world customers, because they are in a very dynamic, highly competitive business environment. They, while the system is getting developed, they are keep telling you, I need this change, I need this change, my competitor has done this particular change, I also like to have it, otherwise I am losing my competitive advantage, right? So I heard that this particular technology has come, so can I integrate that also, because I want all my customers really like my product, not my competitor's product. So likewise, the customer is going to keep on asking for some changes when you are developing the software, as well as the moment you give the release also, he is going to ask you those changes. So that is something you have to tackle, right? You can't say no, no, we can't do any changes. So you are trying to help your customer, right? So therefore, we really need to manage changes. So what are the key features? Complex tasks, high expectation is there. You need multitude of skills. That is why we need a team, right? It's a fast evolving field. Therefore, we have to work with some immature technologies, right? It's always high risk thing. You have to manage changes, right? So those are important. So when you are working in a software development project as a software engineer, you have to aware of those things, right? Otherwise, you are not going to do a good job, right? Otherwise, you are not going to do a job, right? So that means you are not fitted to that situation. Your mindset is not there, right? So it's now let's take one by one. It's of course it has a high complexity and size, right? So that means it has the technological aspects, process related aspects, business related aspects, management related aspects. Then there are multitude of technologies involved, right? UI and design and development, where you will be using JavaScript, HTML, CSS. Application logic development, you will be using either C Sharp or PHP or maybe Java. Then the databases you have to work with. Then of course you have to sometimes work with some network aspects also, if when it comes to there are a lot of third party integrations like payment, integrating with the payment gateways, etc., right? For example, the final year students are now currently doing the project. So some of those students have already started their integration. Some of those students have started integrated with the Google API to get the data from the maps, because whenever we say they are developing a application for cab services or whatever, no point developing a system without integrating to the Google map, right? So that you have to start working on those things, right? Likewise, you have to work to have some network and other integration aspects as well, right? So therefore you can see it's a highly complex things, and of course size wise and the complexity wise, so there are situations where the things is really big but not complex. There are situations it's really complex but not big. But most of the time softwares are, especially if it is an enterprise level software, it's complex and big, right? So that is where we need team members. Why? When things are bigger, one person or 1 or 2% can't do it, you need a team. When things are complex, again, rather than 1 or 2%, we like to have a set of people, then they can get together, discuss, generate their ideas and come up with the best solution, best decisions. So that is why we need set of people, right? Not only because it is big, that is also because it's complex. So rather than one person, set of people, set of professionals can get together and discuss. Okay, so that is what happens if you take medical field. If when they are taking a very critical decisions, right? So say ultimately your doctor decides to amputate the leg. So that person is not going to do that decision. He is going to consult some other doctors and do that. Similarly, when you are taking major decisions in software architecture for a very big project, we need set of architect to get together and discuss that, because some one person may miss 1 or 2 key points. Okay, right? And also it's a highly business demanding nature is there. So that is another thing we have to tackle, because once they get the information system, they are looking for a lot of features, so they are going to do a lot of things, so they are expecting a lot of things in their business. So they want to increase their competitive advantage, they want to increase their quality by using this information system, they want to increase the productivity, they want to look for more opportunities using this information system, and of course they want to have better customer satisfaction because of this information system, right? It might be online system or it might be a normal system, right? So therefore there is a high business demand for this particular product, so you have to tackle that, right? So that business demand you have to somehow cater, right? If you do a really bad job, the customer is not going to get any of these advantages. So that means your customer is really upset, right? So it's a fast evolving field, therefore you have to keep learning, you have to keep learning, right? So every day you have to learn something new. Of course there are people who like to learn, those are really good candidate for software engineers. There are people who hate learn, so they just learn for the sake of getting some uh, certificate only. So those people never, I highly advise them not to go for software engineering field, right? So if you really like to learn new things every day, right? Uh, yes, this is your field. This is your field because it's a really exciting field because you can really learn new things every day because new things comes every day, right? So and also it involves some risk also when you are using a new thing in your project, you are taking a bit of risk, right? You are taking a bit of risk. Uh, so that you have to tackle. So that you have to tackle that kind of skills you must have how to. So that is why we have a topic called risk management also, right? So why when you are picking a new technology etc you have to consider what are the possible risks. Am I going to use this new technology or am I going to use the older version for the time being? Is it too risk? Because always use of a new technology you get a lot of advantages, so right, therefore you try to go into the new technology, that is good, but at the same time if it is too risk you don't want to go into that new technology. Okay, right. Right. Then of course, as I told you, there's a high degree of changes. The customer is going to give you a lot of headaches. So don't consider them as headaches. So consider them as the customer's real need, right? Customer's real need. But you have to manage it. You have to manage it. So that is why you have a subject called project management in your next semester. How to tackle those things, how to manage. So it is not saying no to those things. No, we are going to accept those things in a very systematic way. Okay. Right, now we discuss the nature of software, we discuss the nature of software project, right? So all those challenges, right, demands that we are facing when it comes to software development. Now let's see how to tackle. So why we learn all those things, we want to how somehow tackle those things and be a come up with successful software, right? So that means when I say successful software, that software that is going to fulfill the expectation of your customer. It is not that just it is fulfilling the functionalities. No, using that software customer get the competitive advantage, customer get better quality service. Now once the software is used, the customers are happier, right? Likewise, if you can fulfill all these customers requirements using your software or his expectations, that is successful software. Now let's see how to develop that kind of software using some systematic approach. So we use three main things: use of engineering, right? So that is why you have the software engineering subject here. Use of project management, right? So we want to manage it, so that is why in next semester you have the project management. And use of agile concepts, right? Use of agile concepts, that is why you have the rapid software development subject in your next semester. Though the subject name called rapid software development, the real name is actually agile software development, right? So how do we tackle that? Use of engineering approach, use of project management, have agile mindset, so that is why you have three subjects: software engineering here, project management and rapid software development here. Actually new syllabus, I think in the new syllabus they have changed from rapid software development to agile software development. Okay, right. So those are the three things, right? So you must have all these three things in your mind if you want to be a really successful software engineer, right? Really successful software engineer, right? So engineering approach, why? That is where how we going to tackle the complexity. Project management, that is where we are going to tackle the business demands, because they want the product releases in a reasonable cost. They want things at the deadlines, right? So how to manage those things. Then of course the agile approach, because we want to be very flexible. Agile means flexible when things are really dynamic, when the customers are asking us a lot of different things, right? So that is where we are going to discuss the agile things in your next semester. Okay, right. So now we are going to discuss about software engineering. Now we have come to the topic, right? So we discuss the nature of software, nature of software project. So you have to think about it. Think about real world software project, right? Then you will understand these things. Don't memorize anything, right? So it's never going to work for you. Of course, it might work for your exam, but it's not never going to add any value to your career or your life. Okay, right. So let's see what is meant by software engineering approach. So you can see the terms comes from software plus engineering. So that is called software engineering. Likewise, we have the electrical engineering, civil engineering, mechanical engineering. So this subject is software engineering. So that is what you are learning because you are in the IT, you are following IT degree. Okay, right. So it's a engineering discipline for software development. That is called software engineering. Engineering discipline for software development is called software engineering. Now we have a very good understanding of software and software development. Right now we are going to discuss about what is mean by engineering. Okay. Right. So the term engineering came from a Latin word. I don't know how to pronounce it. Engineer and another term engineer. So engineer means create, generate, or device or something. Engineer means cleverness. So you can see how these terms came. Engineering. So a lot of people who sometimes even some civil engineers, mechanical engineers, they don't know the meaning of engineering, right? So they don't know what they are doing actually, but they have become civil engineers, right? So that is same thing, right? So there are some software engineers, they don't know the meaning of engineering also, but their title is software engineer, right? So that is the funny thing, right? So what we expect from engineers, we expect them to generate, build things in a clever way, not just in a dumb way. So we want engineers to build or generate, design, build new things in a clever way, smart way, right? So that is what is expectation from an engineer. So that is what we expected from software engineers also. Okay. Right. So when engineering is involved, of course, whenever there is a complexity, we need engineers. Right. Whenever there is a patient, illness, we need doctors. Whenever there is a dispute, we need police or lawyers. Right. Likewise, whenever there is a high complex task, which we need a lot of technology, etc., we need engineers. Right. So complex tasks. For example, power plant, building a power plant, building a dam, right, designing a new machine, of course designing a new information system, we need engineers. So why? Because it's a complex task. So whenever complex task is there, we need engineers. If it is a simple task, we just call the programmers, but if it is a complex task, but they need the software engineers. Okay. So nature of engineering, of course, it's involve complexity, because if you are going to solve complex tasks, you must be able to handle complexity. That your process is also going to be somewhat complex. So that is something that every engineer appreciate. They like challenges. So that is why those people who like to face challenges, demanding things, they want to get into the engineering field, right? Other people, they have their own fields, right? So right, so I'm not going to comment on that. So that some people like challenges, some people don't like challenges. Of course, if you are going to manage complexity, handle complexity, you must have that attitude, right? So if you fear of fire, you can't be a firefighter, right? So if you really don't care, or if you like to face some challenges and help others, you become a firefighter. Same thing, if you want to be engineer, you must be able to face that challenge, right? Complexity. Of course, the engineering always involves some technologies, right? And science and mathematics, right? So engineers are built on science and mathematics. So when I say mathematics, it's not logic also. Whenever they take decisions, they use the scientific approach. They use mathematical things and logical thinking. And of course, most of the time, because we are working on a complex and big things, we have to work as a team. We have to work as a team. So that is a very important point when it comes to engineer. When it comes to a doctor, sometimes you can just work as an individual, right? කොහේ හරි පොඩි dispensary එකක් දාගෙන තනියෙන් හරි තව එක්කෙනෙක් දෙන්නෙක් help එක. But when it comes to engineers, they are working on projects like civil engineering projects, mechanical engineering projects, right? So likewise, software engineers also are going to work in a team, right? And also there are some best practices engineering field has developed, so we are going to use those best practices. For example, if you are an engineer, you must know what are the best practices in engineering field, right? So those best practices, if you are going to use it, yes, you are an engineer, right? So of course you must have that attitude, skills, and of course you must be aware of how the what are the best practices in engineering field. Okay, so that is how the engineering field works. Right, now let's see how the engineers work. So engineers work in a specific way, systematic way, right? So how they work is because we need engineers when there are complex big tasks, right? Complex big tasks. For example, if you want to build a wall in your house, You are not going to ask for engineer, right? So you are just going to ask that Basu name. But when it comes to building about 30-story building, no, 30, 40-story building, yes, you need the engineer. So they are going to work with complex things, big things, okay? So how do they tackle it? So they do like this: specification, design, develop, test, evolution, right? So that is how they do that. They are not going to just start developing it. No, first they do the specification, understand the requirements, then they do a proper design modeling of the solution, then only they are going to develop it, or either they are going to develop it or they are going to get it developed by someone else, right? That is another point. When it comes civil engineering, mechanical engineering, engineers do this too, and development is done by workers, right? Workers, right? So that is why we have in civil engineering sites there are a lot of workers. But when it comes software engineering, that is a different thing. In a software project, almost all the people are engineers. So the reason is engineers do the specification, design, and also engineers do the development also, and testing and evolution. So that is why we are the QA engineers, right? So in software development field, all these tasks are done by engineers. But if you take civil or sometimes electrical field, අර electrical engineer කනුවට නැගලා මේ බොහෝ වෙලාවට අර wire high කරන්නේ නැහැ නේද? ඒකට ඉන්න technicians ලා workers ලා. හැබැයි software field එකේදී ඔය nut bolt ගලවන එක තහයි කරන එක පවා තීන්ත ගාන එක පවා කරන්නේ කවුද? software engineer. තීන්ත ගාන එක කියන්නේ හරි UI එකක් develop කරනවා කියන එක. මේ හැමදේම කරන්නේ software engineer. ඇයි ඒ? So that is one reason why software engineering has a high demand, right? So we need not just one or two engineers, we need sometimes hundred of engineers. When a new project comes, they all of a sudden they need 200 software engineers. Why? Everything is done by software engineers, right? Why everything is done by software engineers? Because of the complexity, other people cannot tackle that. Therefore, even that writing the code has to be done by engineers, otherwise the people are going to miss it. So that is another thing, right? If you want to go into the software field, right? So they are not going to take you by just looking at your degree. It's never going to happen. They are going to do lot of interviews and check your mental abilities, your attitudes, and also you are going to be in a probation period, right? If they are not happy, again you will be rejected. Why? A bad software engineer can really mess the system, right? Really mess the system while they are doing some coding and modification. So that is why we need all software engineers doing those things, right? So that is another special feature of software engineering. So you have to understand that yes, software engineering is part of engineering, but at the same time you have to understand the special features of software engineering also. In software engineering, everything is done by engineers. Even small things are done by engineers. Why? Otherwise other people are going to miss it. හරි නැත්නම් software company එකක් කැමති නැද්ද මේ software technicians ලා එහෙම කියලා තව කවුරු හරි ටිකක් අඩු පඩියට ගන්න රුපියල් 5000ක විතර පඩිය 10000ක 20000ක පඩියට. ඇයි මේ ලක්ෂ ගණන් පඩි දීලා ගන්න engineers ලා? අරගොල්ලෝ આવොත් වැඩේ නානවා. අරගොල්ලෝ මේගොල්ලෝ ඇවිල්ලා නාන එකේ. හරි මේ engineers ලා කියන ඩිග්‍රී ගත්ත අයත් ඇවිල්ලා සමහරවල් හාල් පාවර වගේ හැසිරෙන එකේ. අර මිනිස්සුම ගන්න නැත්තේ ඒකයි. හරි සමහරට මේ ඩිග්‍රියක් අරගෙන ඇවිල්ලත් මේක නානවා. මේ තියෙන කෝඩ් එක විනාශ කරනවා. වැඩි කල් ඉන්න දෙන්නේ නැහැ ඒගොල්ලන්ට. හරි. Right, so that is why that is a special feature of software engineering. Okay, right. So how engineers work? Emphasis on analysis, emphasis on modeling, right? Design before develop. So don't just develop, right? Design and develop. Follow the best practices and conventions. For example, the මේ දවස්වල final year project එක නානේ සමහරව design කරන්න නැතුව code ලියන්න පටන් ගන්නවා. මම අහනවා ER diagram ER එක design කරලා ඉවරද? නෑ තාම ER එක වෙන්නේ නැහැ මම දැන් command එහෙම කරන්න පුළුවන්. හැබැයි හරි පොඩි project එකකට ඒක you maybe tackle it, but when it comes to real world project you are not going to be successful. Okay, so design before develop, right? Because otherwise you can't you are not going to get the optimum solution, right? Follow the best practices and conventions, because as I told you, every engineering field has some best practices. Actually, one of the objective of this subject of software engineering is give you the awareness of those best practices in software engineers follow, or software engineering field follows. Test. So okay, so they are not just build something and release, they are always going to test it thoroughly, right? Have maintainability in mind, right? Have the maintainability in mind, so future, right? And also they must be aware of the legal and ethical things. So that is how engineers work. So do you have that mindset? I don't know, right? At the end of software engineering subject, you must be that mindset. So that is what is known as the professional. හරි? ඔයාගේ මේ BIT degree කොලයක් උස්සගෙන ගියා කියලා ඔයාව සමාජයේ professional කෙනෙක් කියලාම ඉන්නේ නැහැ. හරි? ඔයාව ඉන්ටර්වියු එකට ගියාට පස්සේ බලන්නේ ඔයා ගාව මේ attributes තියනවාද? හරි? ඔයාගේ මේ analytic mindset එක තියනවාද? ඔයාට යමක් model කරන්න පුළුවන්ද? ඔයා යමක් design කරලාද වැඩේ පටන් ගන්න develop කරන්න? හරි? ඔයා දන්නවද මේ best practices ගැන? ඔයා යමක් release කරන්න ඉස්සෙල්ලා හොඳට test කරලාද release කරන්නේ? හරි? දැන් සමහරට finally project එක කරාට පස්සේ finally project එක කරන්න ගිහිල්ලා මේ අන්තිම මොහොතේ එනවා සමහර students ලා. මේ supervisor මේක පෙන්නන්නේ. ඉතින් අපි මේක පොඩ්ඩක් flows දෙක තුනක් test කරනකොට අපිට අහුවෙනවා රටේ නැති bugs. මේ මනුස්සයා මේක test කරලා නැහැ. මේ මනුස්සයාට engineering mindset එකක් තියෙනවා මේක test කරනව නේද? මොකක් හරි develop කරලා ඔහේ ඉඳලා. ඉතින් ඊට පස්සේ ඔය ටික ඔක්කොම අහුවෙනවා project defense එකට ගියාට පස්සේ. මොකද ඒගොල්ලෝ මේක දන්නවනේ කතන්දරේ. So you have to test properly, right? Have maintainability in mind, right? Have some legal and ethical aspects also, right? So you must be a professional, right? So you can't do illegal things, you can't do unethical things as part of your, because you get access to a lot of critical systems, right? If you are a software developer for banking system, right? So you might get some hints about melo hint එක නැති ආත්ම system hack කරද්දී ඒ සිස්ටම් එක ඩෙවලොප් කරපු කට්ටියට බොහොම ලේසියෙන් හැක් කරන්න පුළුවන් ඊට පස්සේ නේද? මොකද ඒගොල්ලෝ දන්නවනේ A to Z මේ සිස්ටම් එකේ තියෙන කෝඩින් පවා. හරි මේවයි තියෙන පොඩි තියෙනවා නම් ප්‍රශ්න ඒවත් දන්නවනේ. So we don't expect that kind of behaviors from software engineers, right? We expect them to be really highly professional people, right? So that is very important. Right? So let's take one by one. So you must have the analytical mindset. So what is analysis? So analysis means අපි කියන්නේ මොකද? විශ්ලේෂණය කරනවා. See the big picture, look at the interconnections, identify patterns. If you can see generalized and specialized ideas, extract those things, categorize things. So that is what is mean by analysis. ඔකට තමයි කියන්නේ යමක් විශ්ලේෂණය කරනවා කියලා, right? So engineers must have that mindset, right? Engineers must have that mindset. When you see something, some requirement or whatever, you must be able to do these things, right? So otherwise you are not a good engineer. Then modeling. So as I told you, engineers always model things. So they model at two levels in software engineering. They model the requirements. So that is how you draw your ER diagrams, initial ER diagrams, data flow diagrams, context diagrams, use case diagrams. That is modeling the requirements, right? Then they model the solution. So that is all about designing, right? So that is all about designing. So they model the design, model the solution also. So you can see engineers must have that analytic mindset, and they must capable of modeling, right? They must capable of modeling, right? So we can see different engineering fields. They do a lot of course, not only engineers, even scientists like to model it, right? So this is how you model a benzene, right? So this is how you model electrical system, right? Mechanical systems, civil systems. Of course, when it comes software development field, ER diagram is a model, right? Data flow diagram is a model, class diagram is a model. So you must be having that capability. So that is why you have a parallel subject called object oriented SAD. So throughout that subject, what you do? Model, right? So that is engineering discipline. So you are learning how to draw a use case diagram, how to draw a class diagram, how to draw a sequence diagram, right? How to draw a component diagram. So you can see it's part and parcel of engineer's life, right? If you are really developing a really complex systems, you have to model it. Then only you can understand the things, and also it works as a communication tool, right? So once you give that model to your software developers, they fully understand how the database is going to work, how the classes are going to interact. So you can see it has a lot of benefits, right? So you have to think about those things, right? So if you want to be a software engineer, you must have that engineer's mindset, right? Engineer's mindset. So they must know how to model things, right? ඔයගොල්ලෝ දැකලා තියෙන සිවිල් ඉංජිනේරින් කරන අය ලොකු බම්බු එහෙම දාගෙන යන්නේ. ඒ මොකද සිවිල් ඉංජිනේරින් ඩ්‍රොයින්, මෙකැනිකල් ඉංජිනේර්ස් කරන මේ මැෂින් ඩ්‍රොයින්ස්, right? හැම ඉංජිනේර් කෙනෙක් ගාම මේ ඩිසයිනින් කියන වැඩේදී මොඩලින් කරනවා. හරි? මොකද ඒගොල්ලෝ කරන්නේ කම්ප්ලෙක්ස් වැඩ. Right? So then they do the designing before development, right? So they do designing before development. They never start developing, right? They never start developing without proper design. Why? They know that they are involved in a complex things. They involved in a big thing, right? Big things, complex things. Okay. So part of the designing, they generate various ideas for solution. හරි. ඔළුවට එන පළවෙනි solution එක develop කරන්න යන්නේ නැහැ. ඒගොල්ලෝ බලනවා මේකට මෙහෙම solution එකක් දෙන්න පුළුවන්ද, මෙහෙම solution එකක් දෙන්න පුළුවන්ද, මෙහෙම solution එකක් දෙන්න පුළුවන්ද. So they think about all possible solutions, right? Then sometimes they model solutions also, right? So sometimes they model some few solutions. Then they refine those solutions. හරි ඊට පස්සේ ඒගොල්ලෝ බලනවා මේ solution එකේ මේ advantage තියෙනවා, මේ disadvantage තියෙනවා. This solution has this set of advantage. So they refine those things, right? Then they pick the best solution, right? Best solution, and then they might do the detailed design for that, right? So that is how engineers work. හරි මේ software engineering subject එක ගොනුනාට පස්සේ ඔයාලට මේ mindset එක තියෙන්න ඕන. හරි මේ mindset එක නැතුව මොකක් හරි මේ කොහේ හරි තියෙන MCQ එකකට උත්තරයක් වනලා ආවා කියලා software engineer කෙනෙක් වෙන්නේ නැහැ. හරි ඔයා BIT degree ධාරියෙක් වෙනවා විතරයි. හරි degree එක අරගෙනවා පොල් ගන්න. හරි ඔයාව ගන්න නැහැ මෙලෝ software engineering මේ firm එකකට. හරි මම කියන්නේ හැමෝම software engineers වෙන්න ඕනේ කියලා. හැබැයි ඔයා මේ mindset එක ඇතුව මේකෙන් එළියට යනවා IT degree එක pick කරලා ඔයා ඒකට ආසහන් දන්නේ නේද? හරි so likewise how they do, they generate different solution ideas for solutions, they model those solutions, they refine those, and they pick the best one, and they go into the detailed designing, right? So that is how they do the designing, right? So I just mentioned few things. So they model things, they analyze things, right? So they design things. So there are so many other things. So we mentioned only the key 3 points, right? Right. So then the difference between system engineer and software engineer, right? So software engineers involved in mainly or only software development. But when we say system engineers, we expect them to work in multitude of tasks, like maintaining your hardware, maybe some network related tasks, right? So likewise system administrative related tasks. So if some engineer is involved in those things also, but his main focus is not software development, of course he may involve in some sort of software development as well, then we call them system engineers. හරි ඔයගොල්ලෝ job postings වලට ගියා top jobs වලට ගියාම සමහරවිට ඒගොල්ලෝ ඉන්නවනේ software engineers ලා, සමහරවිට ඒගොල්ලෝ ඉන්නේ system engineers ලා. හරි සමහරු මේ දෙකේ වෙනස දන්නේ නැහැ, ඔහේ මොකටද apply කරනවා. හරි software engineers are, that means you are mainly focusing on software development. System engineers are, they are going to focusing on hardware, system administration, network administration, things like that. Okay, so there is a difference between. So both are engineers, because system engineers also have to tackle complexities, right? Network handle කරනවා කියන්නේ ඔයගොල්ලෝ දන්නවා දැන් ඔයගොල්ලෝ ඊළඟ semester එකේ තියෙන අමාරුම subject එක තමයි මොකද්ද? Networking. හරි so very few people pass that subject, right? So that networking is not a simple thing, right? So we need engineers for that also, right? So those are called system engineers. Right, now we are going to discuss about project management. So remember I told you there are 3 things we are going to use. What are those 3 things? How to tackle this software engineering, software field? Engineering, project management, right, and use of agile concept, right? So anyway, project management you have separate subject in next semester. Agile you have separate subject called rapid software development. Anyway, we are going to just get a feeling of what is project management, because otherwise you can't understand the big picture. Okay, right. So what is project management? So it comes from project plus management, right? So just you can now you can see you must have the analytic mindset. Engineers have that analytic mindset. They know, right, project management. So let's divide it. Project management, how they are related, what are those features. So that is what is meant by engineer, right? So engineers can tackle those complexities. That is why engineers are really good at learning new things also, right? So they are the people who are tackling the complexities. So learning a new subject is also like that, right? So project management means, so you have to understand about what is meant by project, what is meant by management, and how those things are interrelated, right? So basically what we are going to do is what? Manage this project, right? Manage this project, that means tackle this project using the concept of management. Okay, so that is all about project management. Anyway, you have a subject in the next semester. So if you don't have that mindset, how do you learn the concept of project management, or how you become a successful project manager, right? So I know that most of you like to be managers, right? Most of you like to be, very few of you like to be engineers, most of you like to be a manager. Why? ඕගොල්ලෝ ඉතන මැනේජර් කෙනෙක් වුණාට පස්සේ හොඳට අයියෙකුත් දාගෙන ඉවරලා පුටුවක් උඩට වාඩිලා අනිත් මිනිසුන්ගේ මහා දාඩිය මහන්සිය මට ජීවත් වෙන්න පුළුවන් කියලා. හරි ඒ කාලකන්ණි දේ නම් හිතේ තියාගන්න එපා. හරි ඒ කියන්නේ ගොඩක් අය මැනේජර්ස්ලා වෙන්න කැමති නේද? එහෙම බෑ මැනේජර් කෙනෙක් කියන්නේ මම දන්නේ සොෆ්ට්වෙයාර් ෆීල්ඩ් එකේ මැනේජර්ස්ලා ගන්න නැහැ. සොෆ්ට්වෙයාර් ෆීල්ඩ් එකේ මම කියන්නේ ගවර්න්මන්ට් සෙක්ටර් එකේ නෙමෙයි ප්‍රයිවට් සෙක්ටර් එකේ මැනේජර් කෙනෙක් වෙන්න ප්‍රොජෙක්ට් මැනේජර් කෙනෙක් වෙන්න එතන ඉන්න හොඳම සොෆ්ට්වෙයාර් ඉංජිනේර් ගන්න. මොකද හොඳම සොෆ්ට්වෙයාර් ඉංජිනේර් ප්‍රොජෙක්ට් මැනේජර් නැත්තම් මොකද වෙන්නේ? එතන ඉන්න සොෆ්ට්වෙයාර් ඉංජිනේර් ප්‍රොජෙක්ට් මැනේජර් සත පහකට ගණන් ගන්න නැහැ. හරි? සත පහකට ගණන් ගන්න නැහැ. මගේ අතර ඉන්න හොඳම මිනිස්සයා ඉංජිනේර් මගේ මැනේජර් ලීඩ් වෙනවා විසක් මම කැමතිද මගේ අතර ඉන්න හොඳම හාල්පාරුවා මගේ ප්‍රොජෙක්ට් මගේ මැනේජර් කරගන්න. හරි එතකොට මේ මිනිස්සු ගණන් ගන්න නැහැ. හරි? ඔයගොල්ලෝ දන්නා ලංකාවේ ජනාධිපතිලා හිටිය සත පහකට මිනිස්සු ගණන් ගන්නවද? හරි නෑ එහෙම ලීඩර්ෂිප් ස්කිල්ස් තියෙන්න ඕන. මේ මනුස්සයාගේ පෞරුෂයක් තියෙන්න ඕන. ඒකවල තමයි මේ මනුස්සයා කියන දේ සමාජය පිළිගන්නේ නේද? නැත්තම් විකටෙක් වෙනවා. සමාජයට විහිළු සපයන්නෙක් කියලා අන්තිමට දැක්කම මිනිස්සු hina වෙන්න පටන් ගන්නවා. මූණ දැක්කම. හරි? So therefore so it's not that you just get into a post. You must be able to perform your task there, right? So therefore try to understand those things, right? Right. So let's move on. So what is mean by management? Now remember it's all about project management. So management means doing things in a systematic way, right? Doing things in a systematic way. So what is mean by systematic? ක්‍රමානුකූලව යමක් කරනවා. ඔහේ කරනවා නෙමෙයි. Just doing is what? ඔහේ කරනවා. කරන්නම් වාලේ කරනවා. Managing means you do it in a very systematic way. So that is called management. That is called management. So why you want to do things in a systematic way? It get lot of benefits. Okay, so managers, so what is that systematic way? Remember, how do engineers work? So that is very important. How do engineers work? Specification, design, develop, test, evolution, right? So specification එක කරනවා, design කරනවා, develop කරනවා, test කරනවා. ඒගොල්ලෝ modifications එහෙම තියෙනවා ඒව ගැනත් බලනවා. හරි? So how does managers do? Because managers are not engineers. So they do like this: plan, organize, lead, control, right? So if you are a manager or if you know how to do management, right? Of course every software engineer must be a manager also, right? Why? He has to manage his own tasks, right? Of course one of those software engineers is going to be picked as your project manager. That's a different thing because we need someone to take the responsibility of that task. Otherwise everyone is going to say I thought that the other guy is going to do, I thought that this guy is going to do. That is why we need a manager. Actually software engineering field, if you have a bunch of software engineers, the project manager has very little thing to do, right? Very little thing to do. Why? Every software engineer knows what is management. Every software engineer know what is project management, right? So that is why every degree program in IT or computer science, they have a subject called project management, right? So therefore every software engineer know, and also they have a subject called management. You also have a subject called management, right? Fundamentals of management, entrepreneurship, all those things are there. Therefore then, so every engineer knows management, right? So therefore project manager has to do very little things just to coordinate things and make sure that things are happening. Why? We are managing set of professionals who are aware of those concepts, right? So therefore we don't want angling and manage karanna onna anigolam, right? But someone has to take that overall responsibility. So that is why we have project managers. But when you are doing software engineering, you must have that basic understanding of what is management because you are going to be professionals, right? Right. So how do they work? Or how do people who manage things work? Right? You don't have to be a manager to manage, right? You can even manage your BIT subjects, right? So some people just doing it for the sake of doing. Some people properly manage their studying, right? Properly managing their studying. How do they do? Plan, organize, lead, control. Plan, organize, lead, control. So they plan things, right? Before doing something. Then they organize the resources, collect required resources, distribute them properly. Then they take the initiatives. They don't wait until someone asks you to do it. They take the initiative. That is all about leadership. Leadership එක කියන්නේ මොකද්ද? Initiatives ගන්න එක. හරි? මොකක් හරි ප්‍රශ්නයක් එනකොට එක්තන ඉන්න එක මිනිහෙක් ඉස්සරහට ගන්න මේක බේරනවා. අන්න එයාට අපි කියනවා ලීඩර් කියලා. මොකද එයා අනිත් මිනිස්සු මේක කරනකම් බලන් ඉන්නේ නැහැ. හරි? එයා අසාධාරණයක් වුණාම එයා ඉස්සරහට පැනලා ඒක විසඳනවා. නැත්නම් ඒකට වෙනුවෙන් කතා කරනවා, වැඩ කරනවා. So that is leadership. හරි? leadership එක කියන්නේ අන්න ඒකට. So initiatives, take initiatives, right? Then of course when things are not going properly, they know how to control it. they know how to control it. So that is how management work, or that is what the management says, you work like this. It is not only for managers, everyone must know this concept of management, then only they can manage things, right? Plan, organize, lead, then control, right? So every engineer must be a manager of its own task, right? Right, plan, organize, lead, control. So that is how managers work, right? Or that is how people who know management work, right? So then we are moving to the project, because remember, project management, right? Project management. Now you have understanding about management. Now let's move on to the project. So project is set collection of peoples and resources, and they have a common objective to achieve, right? So of course, you may pick one of those your member as a project manager or team leader. So he will guide you, he will control you. Actually, I don't like the word control when it comes to professionals like software engineers. Then he will just guide you. So that is why in your agile software development you will learn that we don't call software development project, we don't have project managers. Actually, we don't have project managers, right? In software development, we have project managers in a lot of other civil engineering, etc. But we don't have project managers in software development team. What we have is uh, someone known as Scrum Master. Scrum Master, that you will learn in your software development. Anyway, we are going to cover that in this one of the slides also. So Scrum Master is just a coach. He is going to just help you, servant leader. They are not authoritarian leaders, they are servant leaders. So they are going to help you, right? So your team leader is going to ask you, what can I help, how can I help you, right? So he is not going to say, have you done this, have you done that, have you completed this? No, he is not going to work like that, because you are a set of professionals. Actually, we expect, if you become a software engineer, of course non-professional people are not never going to be ended up as software engineers. They can do some other things. Hari එවන් පුළුවන් මොන හරි කොළ පුරව පුරව මොන හරි බොරුවක් කර කර ජීවත් වෙන්න ඉතුරු ටිකක්. හරි ජීවිතේ ඉතුරු කාලයක් බොරුවෙම ගෙවලා ඉතුරු කරන්න. හරි. Right. So if you want to do some really challenging things, productive things, right? Some people really appreciate. Yes, you must have these skills, management skills. Okay. Right. So that is how the project looks, right? So set of people and resources, they have common objective or set of objectives to achieve, right? Then project management, when it comes to project management, you have to tackle four things: the time, scope, cost, and quality. So you have to deliver on time, you have to deliver the expected functionalities, you have to deliver within the cost. If it is 10 million, you have to deliver within 10 million. Of course, you can't compromise quality. So you have to deliver your product with the expected quality as well. So that is all about project management. So project management means make sure that time, scope, cost, and quality objectives are met, right? So that is all about project management. Of course, there are some other aspects as well that we are not going to discuss here, because that is where you have one full subject for that, right? So I'm just mentioning the key four aspects only. Okay. Right, so the result of project management is you are going to have better chance of achieving your objectives, because you manage it, you are not just doing it, right? Just doing a exam එකට ගියාම pass වෙන්නත් පුළුවන්, fail වෙන්නත් පුළුවන්, වෙන මොනවා හරි වෙන්නත් පුළුවන්. හැබැයි manage කරපුවා exam එකට ගියාම ඒගොල්ලෝ objective එකක් තියෙන, ඒගොල්ලෝ plan කරා A එකක් ගන්න, A+ එකක් ගන්න, ඒගොල්ලෝ ඒකට organize වුණා, ඒගොල්ලෝ leadership එක අරන් ඒකට වැඩ කරා, ඒගොල්ලෝ පුරාම කරේ වැඩේ අවුල් වෙනකොට ටක් ගාලා control actions ගත්තා, හරි? Right? So that is how they work, right? So they have better chance of achieving this, right? And also they have better productivity. So people who are managing things have better productivity, and also their quality is high. So that is why they are always getting good results, right? So whenever they do something, high quality product is there, right? So better satisfaction to the team and customer. So when you are managing things, you are not getting stressed out, because you are managing things, right? It's not a mess, right? So it's better for the team members and the customer. Customer is also not going to piss off with your work, right? Because he knows that you are doing things in a very systematic way, right? So that is important, right? That is important, right? Then එහෙම finally project එක කරද්දී සමහරම plan කරනවා. හරි? ඒගොල්ලෝ plan කරලා වැඩක් කරනවා. සමහර ළමයි එහෙම නෙමෙයි. අද රෑ 12ට නම් progress report එක දෙන්න තියෙන ඔන්න හන්දෑවේ 10 රාත් 9ට විතර කෝල් කරලා කියන progress report එක එව්වා මේ අනේ මේකට පොඩ්ඩක් approval එක දෙන්න කියලා. එතකොට මොකද වෙන්නේ? So that is better satisfaction for customer. හරි customer ට මල පායිනවා. customer ට මල පායිනවා මේ රෑ 10 වෙනකන් හිටියද මේක එවන්න කියලා. හරි. So they don't have any planning, they don't have any organizing, right? So that is not going to work, right? So you must be professional. Of course there can be very exceptional situations, right, exceptional situation, you didn't get any internet connection, you had some health issue, or you had to do some dependency. Of course that kind of situation we are always uh, flexible. But if it is habit, if you keep doing like that, that means you are not managing things, right? Because we know that that is a habit, not an exceptional situation for that particular instance. Okay, then your customer is going to piss off with your product team, right? So make sure that things are done in a very professional way. Right, now we are going to discuss about the software development process models. Right, software development process models. What are the different ways we can do development of software? Now you have aware of the nature of software development, and how to tackle that. We use software engineering discipline, analyze, design, develop, test, evolution, etc. We use the project management, plan, organize, lead, control, approach, and we are aware of the nature of project, right? What kind of things we want to manage, and also we are aware of how to tackle those customer needs and challenges, changes using agile concepts, right. Now we are moving to the software development process model. So applying these things, we can develop software in different approaches, right? Applying these concepts, right? So general tasks in developing a software are: you have the specification, design, develop, test, implementation, evolution. So that is obvious. Why? In software development team we have software engineers. Software engineers do things in this way, right? Mama kalima kiwane engineers how to deliver specification, design, develop, test, implement, evolution. So then therefore of course every software development project is going to go through that. So that is why every software development project has only engineers, right? Engineers la විතරයි නේ කියන්නේ නේද? Engineers la වැඩ කරන විදිය තමයි software development project එක යන්නේ, right? Right. So specification, that is understanding the requirements and maybe documenting it. Design means modeling the solution, developing that according to the design, test it. Then implementation means basically deployment, right? So don't mean implementation කියන වචනේ development එකේ පටලවා ගන්න එපා. Implementation means deployment, deploying the solution. Then of course sometimes you have to do some maintenance, modifications and stuff like that. Okay, so that is, those are general tasks every software project has to go through. Every software project, if it is software development project, you have to go through, you have to do those tasks. But we can do those tasks in different ways, right? Different ways. Those are called the software development methodologies, right? So the spiral methodology, agile methodology. So just understand the concept. So these are the tasks that every software development project will go through, but we can do those tasks in different ways, depending on the environment and the situation and the ground realities. So those different ways are called software development methodologies. But all those methodologies will cover these 6 tasks, right? These tasks, they will do these 6 tasks in different ways. Okay, so that is the big picture, right? So what is software development process model? So software development process model defines different approaches of developing software. So that means how to do those tasks in different approaches. Okay, each process model covers the basic task in different ways or different patterns. So that is what I explained. Okay, so why we need different process models? Different business and other settings demand different approaches, right? So process model used for this particular scenario is not going to work for that particular scenario. So here we use the waterfall, but now for this scenario, for the next project we are going to use agile, because these business settings and the customer, their expectations are different, right? So it's very important to get that big picture, right? It's very important to get that big picture, right? So let's see what are the key approaches. We have the sequential approach, prototyping approach, iterative approach, and agile approach. So those are the big approaches, right? So under that there are some sub approaches, but in general, sequential approach, prototyping approach, iterative approach, agile approach. So there can be overlapping. Some textbooks will overlap 2 of those things into one. So that is okay, because this is just we want to categorize it, right? To understand, right? So sequential, prototyping, iterative, and agile. So most of the time this prototyping and iterative taken together, I just separate it, right? So let's take sequential approach. So sequential approach means develop the system as sequence of activities, right? So one activity is done. After that, we do the next activity. After that, we do the next activity. So that approach is called sequential approach. So the most popular sequential approach is called waterfall development. So what are the advantages? So when we have sequential approach, we have well-defined stages and deliverables. There are well-defined stages. Each stage has a well-defined deliverable, and also it's very simple and easy to manage because we are not doing only one task at a time, right? And also every task we complete and go to the next task. Therefore, it's very easy to manage that kind of a approach. But this is rarely used these days because of the high business demand and the dynamicity. What we do is, so there are some disadvantages. So it does not suitable when requirements are evolutionary. So because remember we complete the analysis and go to the design, but while you are in design also you will get some requirements, right? So that is not going to work. And long delay before delivery, we are going to give the delivery at the end of the development. So that means maybe after 6 months or maybe after 1 year. So that is high risk, and also the customer is not going to get any competitive advantage or early competitive advantage because he has to wait about 6 months, 1 year to get the product, right? And often we have to the nature of software development is we have to revisit the previous stage, right? If you find a bug and we find that there's an issue in the design, we have to revisit the design. But this says sequential, right? So this says do the design complete and come to the development, but while developing we have to go back to the design. So therefore you can see this is not very practical approach, right? So there are some good things, there are some lot of bad things also, right? So when to use, if the project is simple and the well-known domain, requirements are stable, it's not going to be changed much, and of course customer do not demand early releases. Customer කියන නෑ නෑ මට හදිසියක් නෑ, හරි මට ඔය ඔයා පුළුවන් විදිහට එහෙම කස්ටමර්ස්ලා ඉන්නේ කොහෙද කියලා ඔබ දන්නවද? එහෙම කස්ටමර්ස්ලා ඉන්නේ ආණ්ඩුවේ විතරයි. එහෙම කස්ටමර්ස්ලා ප්‍රයිවට් සෙක්ටර් එකේ නෑ, හරි ප්‍රයිවට් සෙක්ටර් එකේ කස්ටමර් කියන්නේ ඔයාලට පුළුවන් ද මේක ඊයේ දෙන්න කියලා, හරි අද රික්වයර්මන්ට් කියලා කියනවා ඔයාලට බැද්ද ඔක ඊයේ දෙන්න කියලා, හරි. So they are in a highly competitive environment, right? Because so Sampath Bank is competing with HSBC. HSBC is competing with Pan Asia Bank, right? So likewise, Put City is competing with LAF. LAF is competing with Richard Arpico, right? So similarly, Abans is competing with SoftLogic. SoftLogic is competing with Singer. So that is the nature. That is the nature, right? So Pizza Hut is competing with Domino's, right? So likewise, there is a heavy competition. That is the beauty of the private sector. So sequential approach is hardly going to work most of the case, right? Of course, if you are doing it for relax, for your own satisfaction, or for some lazy customer, or you are just doing the project for the sake of project, yes, this is going to work, right? Right, so as I told you, this is how it works: requirement, design, coding, testing. It goes like a waterfall. Of course, there are situations you have to revisit, but you try to make it very minimal, right? Of course, if the requirements are really stable, right, customer is not demanding early releases, I am not criticizing. Sequential approach is pretty good, right? Even for the final year project students also, sometimes we just ask them to go for waterfall, but very rarely we recommend that, right? So some of the students, when they ask waterfall approach, I specifically ask them, no, don't go for waterfall approach, go for agile, go for agile. So that is one reason is when they go for waterfall approach, after 1 month when I ask what they are doing, they will say, okay, I am still gathering requirements. After 3 months, I am now drawing my ER diagram, right? Nothing delivered, right? Maybe after 5 months, they will say, I just start coding, right? I mean, now they have to give the release in another 1 month. They will, so that is the pitfall of waterfall approach. Developers tend to spend a lot of time upfront not doing enough development and testing, etc., right? So that is another thing. A lot of software engineers like to do waterfall, but when it comes to iterative, you have to deliver something very often. So that is why we don't like sequential approach. Then customer knows what is exactly happening. Customer get a feeling of what is happening. Of course, the customer can use it also. So if they are very critical features, okay, right. So then we have the prototype approach. In prototype approach, we develop. So prototype is a working model, right? Working model. So we can use that working model for our advantage. So there are two approaches: throwaway prototyping and evolutionary prototyping. In throwaway prototyping, we build a prototype for a purpose. Once the purpose is fulfilled, we throw it away and we get back to our normal software development. But in evolutionary prototyping, that prototype is going to be ultimately your final product. Right? It evolve to be your final product, right? Gradually. Right? So this is how the throwaway prototyping work. You build the initial prototype, gets initial feedback. If you are satisfied or you and your customer is satisfied, you finish it. Otherwise, you refine it and again show the get the feedback. So you keep doing that. So usually you use throwaway prototyping when we have to clarify some requirements. So if you are not very clear about the customer's requirement, I can build a small prototype of what I thought and show it and ask him whether are you talking something like that. If he says no, this is not what I am expecting, I have to refine my prototype and again show it. Right? So likewise, throwaway prototyping is mostly used when we want to explore requirements, explore possible solutions. So that is another thing, right? I have a solution in mind, so I can just create a prototype and show it to the customer and ask, do you like this kind of a solution? Or I have these two solutions, I will create a small prototype and show, and then he will say, okay, I prefer this one. So likewise, when we want to explore requirements and explore possible solutions, we use prototype. Then we throw away the prototype, we just get back to our normal development. Okay, so the possible pitfalls is spending too much time and money for prototyping, because this is throwaway prototyping. Don't spend too much of time and money, right? So that is something you learn in your user interface design also, high fidelity versus low fidelity, right? So sometimes you don't want to go for high fidelity when you want to clarify a few simple things, okay, because otherwise you are spending a lot of money and time. Right. So don't spend too much. I'm not saying don't spend anything. Don't spend too much of time and money for throwaway prototyping. Then the evolutionary prototyping, what happens is your prototype is ultimately gradually going to become your final product. Right. Your initial prototype is evolved to be your final product. There is a very important point is there, that is, do a initial design and start your prototype. Have your big picture, have the overall scope of the project, have all those things and have proper architecture, have those things set up and then start prototyping, because your prototype is ultimately going to be your final product, right? Final product. ඔයගොල්ලෝ දැකලා සමහර මිනිස්සුන් ගෙවල් දිනනවා. ගේ හදන්න පටන් ගන්නකොට ඔළුවේ තියුන්නේ නැහැ මෙහෙම එකක් හදන්න කියලා. නමුත් පස්සේ මේකට කියන්නේ ඒගොල්ලෝ ඉනිෂියල් ඩිසයින් එකක් නැතුව තමයි මේක පටන් ගත්තේ. යන්තම් කාමර කැලක් හදා ගන්නවා කියලා. හැබැයි ඩිසයින් එකක් කරලා තියුන්නේ නැහැ. දැන් මේකට මොකද කරන්නේ? ඩිසයින් එක නැතුව මෙහෙම පටන් ගත්තාම දැන් මේකට තව කාමරයක් එකතු කරනවා, තව කාමරයක් එකතු කරනවා, සමහරවිට කාමරය එකතු කරලා හදපු කාමරයට අනුව මෙතන දැන් කාමරයක් දාන්න බෑ. දැන් මේකට සාලයක් දාන්න කොහෙත්ම විදියක් නැහැ. අන්න එහෙම වෙනවා මේ evolutionary prototyping වලට ගියොත් එහෙම. So the best thing is, of course, you ඔයාලට එක කාමර කැලක් හදාගන්න පුළුවන්. හැබැයි මම මොකද කරන්න ඕන? ඉස්සෙල්ලා ලොකු ඩිසයින් එක ඔළුවේ තියාගෙන, ඩිසයින් එක ඔළුවේ තියාගෙන කාමරේ හදන්න ඕන දෙන්න කාමරේ හදන්න. මොකද කාමරේ ගලවන්න වෙලා හයි කරන්න බෑනේ. Same thing. So when you are doing evolutionary prototyping, have proper initial design, then develop it, right? Evaluate. Do this as long as it is not completed. When things are completed, you just finish it, right? Of course, every time you are giving a release now, every time you are giving release, this is just a final release, right? So you deliver it to the customer. If he's now, he can give some feedback also, and also new requirements for the next release, etc. So that is how it works, right? And finally it becomes your final product also, right? So it's little bit like iterative, right? So that is why some people just take it to the iterative approach, okay? But this is not really iterative, this is just prototyping, okay? Right. So that we have discussed two approaches, that is, right, that is sequential and prototyping. Now we are moving to the iterative approach, right? Iterative. Of course, the evolutionary prototyping has a lot of iterative approach also, features of iterative approach. Now let's discuss about the iterative development. Right. Again, you must have a very good big idea. So here we have clearly iterations, cycles, right? Like iteration 1, iteration 2, iteration 3, iteration 4. Okay. So at the end of each iteration, we give a release, right? Then the customer can give us feedback, right? So this is our product. Now in the next iteration, another 3 or 4, whatever, 1 month, we give another release. So that release includes the previous functionality plus some more functionality. Then you can see product is getting evolved, getting bigger, and every time we give a release, customer give us a feedback, right? Every time we give a release, customer give us a feedback. Now this is called iterative development, right? So what are the big advantages? You can see it's all of a sudden a lot of advantages are there. Customer can now see what the product is going to be. Now there is no uncertainty for customer, because customer can get a feeling of what kind of product I am getting, right? Then it reduces the risk. And also when we get the feedback, we know whether customer is happy with the way things are going or not happy, right? Otherwise in waterfall, at the end only we know that customer is really upset about our product. But now if the customer is upset, still we get the feedback, we have enough time to rectify, right? So you can see it's a lot of advantage. And also if these are really useful features, sometimes customer can start using those also. Critical functionalities he can start using. Now all of a sudden you can see it reduce risk, right? It gives us better feedback, and also customer get early competitive advantage also. Likewise, you can see it has a lot of good features which you don't find in a waterfall approach. Okay, so that is called iterative development. So this diagram is very important. If you have this diagram in your mind, you know what is iterative development. Some people don't have. They only mindset they have is waterfall, nothing else, right? So in the project also, when I ask them, have you done this? Have you done at least the login functionality? They get upset, because why? They think that they have to do the login functionality after the 6 months. So their mindset is I have to do the analysis, design. ඇත්තට මෙහෙම කරන්න බොරු කරන කට්ටිය තමයි බහුතරයක්. වැඩි කරන්න නොකරන පැත්තට තමයි යන්නේ. හරි? So therefore you must ready for these kind of real world software development now, because next year anyway you are going to do your final year project. Okay, right? So there we expect you to do iterative approach, where you do some product demo to the project supervisor, maybe every month. You may start with very simple functionality, but then the product supervisor is actually like your project manager or the Scrum Master, as well as the project supervisor is something like your customer also. Of course you can have separate customer, but as a customer also we look at the product when you are demonstrating your product, and we say, okay, this UI is not good, please refine the UI, something like that. So I don't like the way the dashboard is designed, so I like something else. Of course you can get feedback from me as well as feedback from your customer, right? But so there is no enforcement saying you have to incorporate all the feedback that your customer is giving or that your supervisor is giving. But we can help you, right? We can help you, guide you. Of course we can help you and guide you if you follow these kind of software development approach. If you follow waterfall approach, what will happen? You are not showing me anything, right? First month, no. Second month, no. Third month, no. Right? Because waterfall, right? And when the project is due in November first week, come and show me some product. Now I see hundreds of issues, but you don't have enough time to fix those things, right? Because some of those things are design related things, right? So many issues are there. So therefore, if you go for iterative development, it's very smooth operation, right? Your customer is also happy, you also have no problem, because otherwise you are under stress, you have a lot of uncertainty, you don't know whether your customer is going to like your product. But now you know what is going to happen, right? What is going to happen, right? Good or bad, early feedback is very important. Okay, right? So we discussed the good and bad things. So under iterative development, we have the spiral approach, rapid application, rational unified process, RAD or the RSD, right? So I am not going to go into detail about those things, right? So those are some variations of iterative approach, right? For example, if you take rational unified process, it emphasizes on modeling. So you have all those things in your handbook. Right? Emphasize on modeling, emphasize on architecture, emphasize on customer focus, emphasize on reducing skills. So those are some variations of iterative, right? Then in rational unified process, we have well-defined phases like inception, elaboration, construction, transition. Some iterations are inception, some iterations are elaboration. Then we have different roles: modeling role, implementation role, test role, etc. Right? So that you have to go through your notes, right? Then we have the rapid software development, where it's also iterative approach. So what are the key features in rapid software development is, anyway you have that subject in your next semester, though we are talking about the agile concepts they are mostly. You have the short iterations. So iterations are about 2-3 weeks only, right? So every 3-4 weeks we give a release, right? Then time box. These iterations never get drags. If you have deadline for next Friday, we definitely going to release it on next Friday. So time box iterations, right? Frequent delivery. So that means short iterations means what? Frequently we deliver, right? High customer involvement. So likewise, if you follow these additional practices, we call it rapid software development. Rapidly, we are delivering our product to the customer, right? Every 3-4 weeks we have release, right? Every 3-4 weeks we have release. So that is important, right? Right. How to do? Of course, you can't do rapid software development in all the cases. The first prerequisite is you must have very competent and motivated team members. Right? Very competent and highly motivated team members. Then only they can quickly do some releases, right? හැම සති හතරකම සැරයක් රිලීස් එකක් දෙන්න බෑනේ මේ ඔයාලට හැරෙන්නත් විනාඩි 5ක් විතර යනවා නේද හැරෙන්න ඈනුවක් එහෙම අරලා නම් කෝඩ් කරන්නේ එහෙම බෑ එහෙම දක්ෂ හොඳට software develop කරන ආස කට්ටිය ඉන්න ඕනේ team එකේ then of course they are going to do that, right? High customer collaboration. From customer side also we need good collaboration, right? We need good collaboration. දැන් උදාහරණයකට ඔයාලට කැමති releases දෙන්න සතිය හතරෙන් හතරට customer උනන්දු නැහැ. Is it going to work? No, it is not going to work, right? So there are some students who are doing final year project, right? So they are willing to show me the demonstration, right? Every 2 weeks time. හැබැයි එයා මට ටෙක්ස්ට් එකක් දැම්මම මේ WhatsApp එකට ටෙක්ස්ට් එකක් දැම්මම මගේ ප්‍රොඩක්ට් එක පොඩ්ඩක් ඩෙමොන්ස්ට්‍රේෂන් එකක් කරන්න පුළුවන් වෙලාවක් කියන්න කියලා. මම එයාට රෙස්පොන්ස් කරන්නේ නැත්තම් අපිට රැපිඩ් ඩෙවලොප්මන්ට් කරන්න පුළුවන්ද? බෑ. නේද? බොහෝ විට එහෙම දැම්මම මම කියනවා හරි දැන් මම බිසි ඔයාට හෙට 12 ඉඳලා 1 අතර කාලේ කෝල් කරන්න. නැත්තම් ඔයා 6න් පස්සේ පොඩ්ඩක් කෝල් එකක් දෙන්න Zoom කෝල් එකක් දෙන්න. So likewise the customer must also collaborate. If the customer is also collaborating only, you can do the rapid development, right? Then of course you have to use the tools and frameworks, etc., right? So it is not that you can just do the rapid development using your notepad and command prompt. You have to use your productivity tools like integrated development environment, build tools, right, etc. Then only you can go for rapid software development. Okay, so when to use? When the customer need early competitive advantage. So that is the very, very critical. When the customer really need it fast, we have to respond to the customer's need, right? So therefore don't use it for very critical applications like life saving systems, missile guide system, because we are going to do things very fast. There can be small mistakes here and there which we want to fix fast, but don't do it for very critical things. Okay, right? Then the final approach is called agile development, right? So agile development is the modern, the most of the time we use the agile approach right now. So agile development is based on two things: agile philosophy and agile approach, right? Agile development is based on agile philosophy and agile approach. So we briefly mention what is agile philosophy and agile approach. Okay, so agile philosophy. So philosophy means what? Way of life, way of living. ජීවත් වෙන විදිහකට තමයි අපි කියන්නේ දර්ශනයක් කියලා, right? So in agile philosophy it's talk about simplicity, leanness, lightweight, customer focus, low ceremony, etc. So that is very important. Lot of students don't have that agile mindset to agile philosophy. Their life is not agile. Their life is very rigid, right? So do things in a very simple way, right? Do things in a very simple way. Leanness. So leanness means what? When we want to spend some time or resources, we spend time and resources only when it is absolutely necessary. Like we don't spend time and money for unnecessary things. Lightweight. Don't make things very heavy, right? So your frame, your software product also, your UI also, it has a minimum things. It has the minimum things. So that is called lightweight, right? Then the customer focus. Whenever you develop something, look at your customer's requirement. Don't develop what you like. Develop what your customer really want, right? So low ceremony. There are no ceremonies like this. So ජනවාරි පළවෙනි දිනත් සෙරමනි හැමතැනම උත්සව සාකච්ඡා ඒව නැහැ agile development වල. So we have, for example, every day we have a stand up meeting, right? ඒක වාඩි වෙන්නවත් නැහැ meeting එකේදී, හිටගෙන meeting එක තියන්නේ. මොකද වාඩිනාවනේ මිනිස්සුන්ට ආයේ නැගිටවන්න ක්‍රේන් අරන් එන්න වෙන්නේ. හරි වාඩිනා මිනිස්සු කැමති වාඩිලාම ඉන්නේ. So stand-up meeting එකක් තියන්නේ everyone get only maximum 2 minutes to discuss his problems or whatever. Within 20 minutes, the meeting is over. Meeting is over. Then they get back to their work, right? Because then they have a lot of time. Not only time, they have a lot of free time also because they are not wasting time with unnecessary ceremonies. හරි ඔයගොල්ලෝ දන්නවනේ ඔයගොල්ලන්ගේ ජීවිතේ සමහර වැඩිම කාලය ගෙවලා තියෙන්නේ මගුල් ගෙවල් වල මල ගෙවල් වල හරි ට්‍රිප් නම් කමක් නැහැ කියමු හරි ඔය එක එක සෙරමනීස් වල තමයි ජීවිතේ ගෙවලා තියෙන්නේ හරි so that is not agile philosophy, that is not agile ගිහිල්ලි වල මූණවල් දිහා බලාගෙන ඉන්නවා හරි right. So that is agile philosophy says don't go for ceremonies, work on your product, spend your time for productive things, right? So that is called agile philosophy. So that is how the modern software developers work. ඔයගොල්ලෝ දැකලා තියෙනවද මාක් සකබර්ග් දැක්කොත් එහෙම මාක් සකබර්ග් කොයි වෙලාවෙත් ඉන්නේ ලානිල් පාට ටී-ෂර්ට් එකක් ගාගෙන මිනිහා ඉන්නවද මේ ටයි කෝඩ් දාගෙන අපේ අය න ටයි කෝඩ් දාලා තවත් මොනවා හරි එකක් දාගන්න උදින් හරි එහෙම ප්‍රොෆෙෂනල්ස්ලා තියෙනවා ලෝකෙට නිකන් අර බොරු මවාපෑම් දාන ප්‍රොෆෙෂනල්ස්ලා ඉන්නේ ටයි එකක් දාලා කෝට් එකක් දාලා ඒක උඩින් තවත් එකක් දාලා software developers ලා එන්නේ software developers ලා ටී-ෂර්ට් කැල්ලක් ගහගත්තා වැඩ කරා මොකද මේ මිනිස්සු වැඩේ ගැන මේ මිනිස්සු කන්සන්ට්‍රේට් කරන්නේ මේ මිනිස්සුන්ට මේ ඇඳුමින් ඉම්ප්‍රෙස් කරන්න දෙයක් නැහැ හරි මේ මිනිස්සු සෙරමනි දීදී ඉන්නේ මේ මිනිස්සු සෙරමනි තියන්න ඕනේ මේ මිනිස්සු ප්‍රොඩක්ට් එක හැමෝම යූස් කරනවා හරි හරි ඇවිල්ලා මේක මේ උත්සව තියන්න මේ මගුල් බෙර ගහන්න හරි පොල් තෙල් පහන් පත්තු කරන දෙයක් නැහැ හොරෙම ප්‍රොඩක්ට් එක රිලීස් කරනවා සමහරවිට ඔයගොල්ලෝ දන්නේ නැද්ද මාක්ස් අප් වලට මෙච්චර ප්‍රොඩක්ට්ස් තියෙනවා කියලා නේ Facebook තියෙනවා Messenger තියෙනවා හරි අනිත් පැත්තෙන් WhatsApp එක තියෙනවා අනිත් පැත්තේ Instagram එක තියෙනවා ලෝකේ පළවෙනි කෝටිපති මේ මිලියනර්ස් 10 දෙනා අතර ඉන්නවා මිනිහා ෂර්ට් එකක් ගහගෙන ටී-ෂර්ට් එකක් ගහගෙන ඇවිදිනවා හරි කොහේ හරි යනවා හරි එක්සර්සයිස් කරනවා ඒක කරගෙන ඉන්නවා right. So that is agile philosophy, that is what we expect from software engineers, right. Then the agile approach, right, agile approach, that is we have two approaches, Scrum based development and extreme programming. Okay, Scrum based development and extreme programming. So when it comes to Scrum based development, so we do have specific approach, so that I am not going to discuss, so you have to refer to the handbook, right. So what are the features? Small team size of 6 to 9 members, sprint of 1 to 4 weeks, the sprints are time boxed, right. Then roles, you have the Scrum Master, product owner and team members. You can see there is nothing called project manager, right. Man kon project managers ලා දාන්න නැහැ කියලා software developers professionals ලා manage කරන්න දෙයක් නැහැ. Professional project management දන්නවා, right. Scrum Master, product owner and team member. And artifacts are product backlog, sprint backlog, burn down or burn up chart, story cards and potentially shippable product increment. So අපි මේ දෙන්නේ product එකට කියන්නේ මොකක්ද කියලා release එකේදී potentially shippable product. ඒ කියන්නේ ඕන නම් customer use කරන්න පුළුවන් product එකක් තමයි දෙන්නේ. හැම release එකක්ම මෙයා use කරන්නේ නැති වෙයි. හැබැයි ඕන නම් යාට use කරන්න පුළුවන් level එකට මේක හදලා දෙන්නේ. Right? So that is how Scrum based development work. I just rushed through it, right? Then we have the extreme programming also, part of Agile Approach. There also we have a lot of overlapping, small team size, short time box iterations, emphasis on unit testing, pair programming, continuous integration to the main build, etc. Right? So those things are there, right? ඔයගොල්ලෝ පේනවා දෙන්නේ continuous integration to main build කියන එක තමයි ඔයාලට හැමතිස්සෙම. ඉස්සර එහෙම නැහැ. දැන් ඔයාලගේ Firefox එකේම සති දෙකකට විතර සැරයක් අප්ඩේට් වෙනවා. Windows වල නිතරම releases එනවා. Why? Continuous integration. ඒගොල්ලෝ සති දෙකකට විතර සැරයක් ඒ develop කරපු ටික customer දෙනවා. කස්ටමර් අපිනේ අපිට Firefox update එක එනවනේ. ඔය ගොඩක් tools මම දන්නේ මාසෙකට සැරයක් updates එනවා. Why? They are using these agile concepts, right? Agile concepts. Otherwise, customer is not going to happy with you. Customer is going to happy with the products. They are giving the frequent releases, right? Frequent releases, right? So මේක මේ theory එකක් කතා කරලා ප්‍රායෝගික ලෝකෙ වෙන එකක් වෙන්නේ නැහැ. මේ theory එක තමයි ප්‍රායෝගික ලෝකෙ වෙන්නේ. ඔයාලට Firefox වලට එහෙම releases එනවා. ඔයාලට ගොඩක් tools වලට මාසෙන් මාසෙට එනවා. Why? They continuously integrated it to the main product. Right? Product develop කරනවා ඒක release කරනවා. Product develop කරනවා ඒක release කරනවා. Right? Develop කරනවා කියන්නේ තිවිච්ච එක උඩ. So then customer get more and more features very fast. Otherwise what will happen? Firefox එකේ එනවා සතියකින් සතියකට. Google දෙන්නේ අවුරුද්දකට සැරයක්. මිනිස්සු ඔක්කොම ටික දවසක් ඇවිත් Firefox වල. මොකද අර අවුරුද්දක් බලන් ඉන්නකොට මේ features මෙතන මාස දෙකකින් ඇවිල්ලා. මාස දෙකකින් ඇවිල්ලා Firefox එකේ. Right? Right. Now we are moving to the software development life cycle. As I told you, how the engineers work: analyze, design, develop, test, and evolution. So that is the rest of the syllabus, right? If engineers work like that, that must be your syllabus, right? How do engineers work? Analyze, design, develop, test, and evolution. So similarly, you have the project management subject in next semester. As I told you how the managers work: plan, organize, lead, control. You look at your for project management syllabus in your next semester, you have all those as topics. So here, because you are doing software engineering, you have all those things as your topics, right? Analysis, design, development, testing, evolution, right? So that has to be right. If it is software engineering, you must have those topics, right? Right. So now let's move on to the analysis. Right. So analysis is all about understand the requirement. Therefore, first you have to understand what is mean by requirement and what are the different type of requirements, right? So you don't need after some time you don't need a handbook, right? Because you know once you have that engineer's mindset, software engineer කෙනෙක් වුණාට පස්සේ software engineering note එක අරන් කියන්නේ නැහැ නේ වැඩට. ඔයාගේ ඔළුවේ තියෙනවා මේ. හරි මම software engineer කෙනෙක් නම් මට වැඩ කරන්න තියෙන මේ වගේ field එකක් එක්ක මම වැඩ මේ දවසේ මම requirements එක වැඩ කරනවා. requirements කියන්නේ මෙහෙම දෙයක්. ඒ ටික ඔයාගේ ඔළුවේ තියෙනවා right. දැන් උදාහරණයක් මම මේ note එක මම මේ PowerPoint presentation එක හදද්දි මම බොහොම කලාතුරකින් තමයි note එක බලන්නේ. මම මේ PowerPoint presentation එක type කරගෙන යනවා. type කරගෙන යනවා. අර ඕගොල්ලන්ගේ syllabus එක කරනවා හදන්න ඕන නම් සමහරවිට මම double check කරනවා. මේක තියෙනවද කියලා. ඒ වගේ ඔයාගේ ඔළුවේ තියෙන්න ඕන. මොකද්ද මේ software engineering කියන්නේ කියලා නේද මොකද්ද මේ software engineering කියන්නේ කියලා if you want to be a software engineer right ඔයාගේ ඔළුවේ ඒක නැතුව ඔයා උදේට වැඩට ගිහලා වැඩක් නැහැ නේද උදේට වැඩට ගියාට ඔයා engineer කෙනෙක් නෙමෙයි ඇවිල්ලා තියෙන්නේ ඔයා ඇවිල්ලා තියෙන්නේ නිකන් මිනිස්සෙක් ඇවිල්ලා තියෙන්නේ BIT ධාරියෙක් නෙමෙයි ඒගොල්ලන්ට ඕනේ මොකද්ද software engineer කෙනෙක් right so what are the different type of requirements so we can subdivide again functional requirements non-functional requirements domain requirements right so unless you know what are the type of requirements you are not going to do requirement analysis right කරන්න තියෙන්නේ මොනවද කියලා දන්නේ කොහොමද ඒව analyze කරන්නේ right so functional requirements non-functional requirements and domain requirements so those are three type of requirements so functional requirements means the functionalities right functionalities for example customer will say I need the creating orders I want to create some handle payments so those functional requirements non-functional requirements means some other quality attributes and restrictions we need right for example performance related things user friendliness right maintainability right interoperability so those are non-functional requirements so those are also important right then we have some domain requirements so specific domains will say you have to have those things fulfilled if it is a banking domain there are some rules if it is an airline reservation domain so they have some conventions and rules regulations because they have to interoperate so unless you have comply with those things actually that airport is not going to accept your product because they will say no we can't operate this because you are violating the domain requirements therefore we can't interoperate with other airports or airlines so therefore you have to think about those domain requirements as well right so functional requirements non-functional requirements domain requirements are especially important when it comes to banking airline and that health that kind of special cases okay because each domain has their own domain requirements right so this is how you do requirement analysis that stage you gather requirements analyze the requirements model the requirements document the requirements verify the requirements so it's very important to have that mindset otherwise you are going to miss one or two of those steps so right gather analyze model document verify right so how to gather requirements you can do interviews observations questionnaires study the existing document and these days the most important one is joint requirement plan JRP actually in agile software development we do only this one right 99% of the time we do the JRP therefore pay a lot of attention to this joint requirement planning means you get together your customer and you team members all the team members get together and discuss what are the requirements right so that is very effective way so these are the traditional ways සමහරුන්ගේ ඔළුවේ තියෙන මේ ටික විතරයි හරි ඔයගෙන් ගොතේ වැදගත්ම විදිය මොකද්ද දැන්ට පාවිච්චි කරන්නේ joint requirement planning team members and the customers get together and discuss so that is why we need lot of soft skills from software engineers now ඉස්සර software engineer back end එකේ code කරනවා customer face කරන්න යනවා business analyst customer face කරන්න යනවා business analyst හොඳට කඩ දින හරි business concept ගන්න එයාව යවනවා software engineer පස්සට වෙලා ඉන්නවා දැන් ඒව බෑ දැන් team members ලා කෙලින්ම customer ත් එක්ක one to one discuss කරන්න ඕන. හරි functionality එකක් දුන්නම software engineer කෙනෙක්ට නැත්නම් team member කෙනෙක්ට ඒක requirement clarification එකක් කරන්න ඕන නම් කෙලින්ම customer ට call කරලා නැත්නම් call එකක් අරගෙන customer කෙලින්ම requirement customer clarify කරගන්න ඕන. right ඒ වගේ joint meeting වල ඔක්කොම team members ලා එන්න ඕන. so that is what is called joint requirement plan JRP. okay so don't learn old stuff right 1980 ගණන් වල software engineering ඉගෙන ගන්න එපා. හරි ඔයා ඉස්සරහට ලෝකෙදී පවතින සහ දැන්ට පවතින software engineering ඉගෙන ගන්න. සමහර software engineering කියලා ඉගෙන ගන්න 1980 ගණන් වල පොත්වල දීවිච්චා. හරි right so then analyze the requirements. so as I told you, analyze means see the big picture, identify the interconnections, identify the patterns, generalization and specialization, categorization. You do all those things together. That means you have analyzed your requirements, right? ඔය ටික අහන් ඇවිල්ලා ඉන්නේ නැහැ නේ ඉස්සෙල්ලා. so ඒක ඔළුවේ වෙන වැඩක් වාගේ. හරි so ඒක වාගේ පළපුරුද්දත් එක්ක එනවා. then also you want to model it. so once you get it, you analyze it, now you want to model it, right? model it using lot of diagrams. so that is where you have in system structured system analysis and design is a process and data approach, where you have the for the data you have the ER diagram, for the process you have the context diagram, data flow diagrams, etc. right that I am not going to go through because you had the system analysis and design subject in your semester 2, and of course for data you have the ER diagram, right? that is structured system analysis and design. when it comes to object oriented system analysis and design, you have the for the analysis, I am only interested about analysis. You have the use case diagrams and use case descriptions. okay so here you have the process and data separately for the analysis. These different models. Here you have the use case diagrams and use case description. You are following those things in your other subject, object oriented SAD. okay right so in traditional approach, the documentation we are now talking, right? so we have something called software requirement specification. The formal, actually there's a mistake in the heading. This should be not model requirement, this should be document the requirements. In traditional approach we have something called software requirement specification, a formal document given to the customer. But in agile approach we call them user stories. so likewise you must have the old approach, new approach also. We call them user stories. We take those user stories document in our artifacts. Like if you refer to this diagram, we have the product backlog and sprint backlog. so there we have the user stories. Those are just Excel sheets, very informally, casually we do. That is part of the Scrum based development, right? Agile development. Agile development එක තව ගැත්ත වෙනවද? අපි හරි casual විදිහට වැඩ කරන්නේ. formal විදිහට වැඩ කරන කට්ටිය තමයි ඔය පොල් තෙල් පහන පත්තු කරලා කෝඩ් බෑ දාගෙන මගුල් බෙර ගහලා වැඩ කරන හාල් පාරුවෝ. හරි ඔයගොල්ලෝ දැක්කනේ මාක් සකබර්ග්ලා ටී-ෂර්ට් එක ගහගෙන casual විදිහට වැඩ කරන software developers ලා, software engineers ලා. ඒ මිනිස්සු මේ ජයමංගල ගාථා අහන් ඉඳලා සතුටු වෙන්නේ නැහැ. ඒ මිනිස්සු තමන්ගේ ප්‍රොඩක්ට් එක මිනිස්සු පාවිච්චි කරන එක ගැන සතුටු වෙන්නේ. හරි. ඒ මිනිස්සු තව කෙනෙක් යනකොට හිතගත්තා කියලා සතුටු වෙන්නේ නැහැ. ඒ මිනිස්සු තමන්ගේ ප්‍රොඩක්ට් එක ගැන හොඳ කිව්වා කියලා තමයි සතුටු වෙන්නේ. Right. so that is the difference. right so in documentation, in new approach, we use just the user stories. හරි පාවිච්චි කරන වචනත් ඉතා සරලයි. user කියව කතන්දරයක්, right? user stories, it's informal documentation, right? then of course you have to verify your requirements. If it is traditional approach, you have to give that document and verify. But in agile approach, always we are in a dialogue with the customer. You can always casually verify your requirements with the customer. Very important, verify කරගත්තේ නැත්නම් මොකද වෙන්නේ? ඔයා මොන හරි requirement එකක් කියලා හිතා ගන්නවා. ඒක නෙමෙයි ඇත්තටම customer ගෙන් ඔයා verify කරගෙන අන්තිමට ඒක develop කරලා. develop කරාට පස්සේ තමයි දන්නේ මේක නෙමෙයි customer ගේ requirement එක කියලා. so it's a very costly thing. very costly thing, right? so don't work on assumptions, right? when it comes to real world software development, always verify things from your customer, right? Then of course the requirement evolution, always there's chance of your requirements getting changed, especially in the dynamic business environment. The customer is going to ask you a lot of changes. Don't take it as a negative thing. Why customer asking you to do some changes? Because customer really need it. Without that, customer can't survive. so we have to look at from their point of view, right? because they are not going to ask you changes to just to bother you, right? Of course, if that kind of mindset is with your customer, you have to tackle that separately. That you must send him to psycho case එකක් එහෙනම්. usually customers are not going to bother you. He is asking those changes because he really need those changes to run his business. So we have to manage it. So that is called requirement evolution, right? But make sure you have to replan it, you have to recost it. හරි වාට බෑ මේ කලින් පොරොන්දු වෙච්ච ගන්නට මේ change කරපු requirement එක දෙන්න. ඒකට කියනවා හරි. We can do it, but we need additional 1 week to do that, and there will be additional this much of cost. ඔය ඔහොම නොකරාම තමයි ඔය රෑලි වෙනකන් software developers develop කරන්නේ. ඔයගොල්ලෝ දන්නවනේ මේ software engineers නෙමෙයි කියලා field එකේ ඉන්නේ. හරි? මහා අල්පාරුවනේ ඉන්නේ. එතකොට ඒගොල්ලෝ එහෙම renegotiate කරන්නේ නැහැ customer එක්ක. changes ඕන එක බාර ගන්නවා. මොන team members රෑ 12ක නෙමෙයි රෑ 3-4 වෙනකම් වැඩ. ඇයි? ඒගොල්ලෝ additional cost කරලා නැහැ, additional විදිහට replan කරලා නැහැ. එහෙම කරන්නත් බෑ. That is why we need some professionalism from software engineers. If the software engineers are not professional, of course they are going to come home at 2 p.m. 2 a.m. in the morning, right? Why? Don't blame the customer. You are not professional, right? You are not professional. You have not learned those things properly, right? Then, so that's it for the analysis. I am not going through everything. I am just highlighting the important things for your career, right? So not for the exam. I don't care about your exams. I don't care about your BIT or whatever degree at all if you don't have those qualities, right? Of course I value your degree if you have those qualities, right? If you have that attitude, I highly value your degree. Your degree has a lot of value, but with those qualities, right? Without those qualities, only your degree, any degree, even a PhD, I don't care, right? So ලංකාවේ PhD තියෙන ඇති ඉන්නවනේ ආචාර්ය මර්වින් සිල්වාගේ ඉඳලා හරි තව දේශපාලන පුතුන් ඉඳලා සතපාකට මිනිස්සු ගණන් ගන්න අර පස්ස පැත්තෙන් යන හාල්පාරෝ වහලු ගණන් ගන්නවා අනිත් මිනිස්සු අතපහකට ගණන් ගන්නෑ, right? So that is same thing, right? So have your degree or whatever, but have those competencies and especially your mindset, right? Your attitude, right? So now we are moving to the design. So as I told you, design is modeling the proposed solution, right? So the actual modeling is just part of it, but the main thing is we don't just start developing. First we want to design because we are working with some complex things, right? Big things. So we want to so why we need design? Complex systems cannot simply build. So that as simple as that. You might start building it, but after sometimes you feel like no, it's not going to work, right? Think long term maintainability, right? So don't just think about the releasing this and අතහොල ගන්න හරියන්නේ නැහැ. So if you want to do some long term things, you have to do proper design and also scalability. So what is mean by scalability? When the product is going to be started, then more and more people are going to be started. Now remember, while using those products, your customer is going to be grow, right? So when the customer, his business is growing, now not only 100 people, at a particular time your web application is used by 1000 people. So think about those things upfront. That is why we need to do a proper design, right? And also identify the optimum solution. So there might be hundreds of solutions coming to your mind, but you have to out of these you have to consider what is the best solution, right? So that is why you need little bit of patience upfront. That is why you need a phase called designing. Okay, right? So what are the tasks? You have to do the high level design, we call it architecture, and then you can go to the designing of the components or the detailed design, right? So first you must have the architecture or the high level design, then you go for the detailed design or the designing of each and every component and how those components are interacting with each other. Okay, right? So let's look at some popular architectures. So if you are aware of architectures only, you will pick one of those architecture which is best suited for your application. So yeah, I got disconnected due to power outage. Can you all hear me now? Can you all hear me?
Yes, sir.
Okay. So I just get back to my other internet connection. Right. So there are some popular architectures. So you have to be aware of those architectures. Then only you can use those architectures. So then only you are going to use those architectures. If it is, so what are the popular architectures? We have the standalone architecture. If you are not going to connect it to the network, that is the case in some cases. Then you have the repository architecture, client server architecture, centralized versus distributed, peer-to-peer architecture, layered architecture. Likewise, there are architectures. I am not going to go into details. So you have to pick the architecture, or sometimes you have to combine one or two architectures together and use the best architecture that you want to have. Okay, so that is very important. So that is the high level design. Now we are talking about designing, right? So if you are doing software engineering, you have to go through those things, right? Otherwise you are not doing engineering, you are just doing something else, right? So engineers always come up with the design. Initially they come up with the architecture. Okay, right? Then there are some concepts related to detailed design, right? So detailed design means designing the components, right? So two of the most important concepts are cohesion and coupling. Cohesion and coupling. So you have to be aware of those two concepts, right? Cohesion means when you take a module, it does one well-defined things. When it does one well-defined things, it is going to have only the subcomponents which are really cohesive. Cohesive කියන වචනේ තේරුම මොකද්ද? ඇලෙනවා. හරි ඇලෙන්නේ සාමාන්‍ය ඇලෙන්නේ එක වගේ කට්ටියද අකමැති කට්ටියද? අකමැති කට්ටිය ආශ්‍රය කරන්නේ නැතුව අයින් වෙනවා. කැමති කට්ටිය එක්කෙනාට එක්කෙනා ආශ්‍රය කරනවා. So that means if they are really related functionalities in one module, that means it's highly cohesive, right? So that is what we need. We need highly cohesive modular structure. Only related things must be there, right? Then coupling. So coupling is a bad thing. Coupling means how often one module is communicating with another module, right? So we want to minimize that. We want to minimize that. So when the coupling is minimum only, these modules are going to be more and more independent, and also there will be better performance also, because they don't have to communicate with other modules frequently. So that means highly cohesive and low coupling means your product is highly maintainable and also your modules are highly reusable. So those are the two important things. When cohesion is high and coupling is low, basically those are natural things. When cohesion is high, naturally coupling is going to be low. That means your modules are highly reusable, your product is highly maintainable. Okay, so those are very important, right? Then so that is mostly a structured concept. When it comes to object oriented designing, we have four concepts: abstraction, encapsulation, inheritance, and polymorphism. So I'm not going to cover all those. I'm not going to cover those things. Those things we have covered in our object oriented programming in our semester 2. So but you have to be aware of those things. So because you are in semester 3 means you must have that skills, right? I'm not saying knowledge, you must have that skills, competencies take from your semester 2. Okay, right? Now we are moving to the coding. Right, now we are moving to the coding. So now remember, I spent a lot of time upfront to set the background mindset. Now I am going very fast because I know that now you can pick those things very fast, right? Once you have that engineering mindset. So my main thing is having that engineering mindset, right? So right, otherwise you are not going to tackle this. Of course you might tackle your exam, but you are not going to tackle the complexity of the software. Now remember, in the final year, right? So when about 100 students start their final year project, only about 40-50 students finish it. Rest of the people, I don't know what happened to them. After some time there is no sound from them. No sound from them. Why? They don't have that engineering mindset, right? They don't have that engineering mindset. They don't have that engineering skills, right? Tackling complexity, systematically doing things, right? Also they don't have that management skills, right? Of course after sometimes they quietly, right, get rid of the project, or get rid of the project the project get rid of you, right? Because the project, you can't tackle that project, you can't tackle that complexity, you can't tackle how to work in real world environment. So therefore it's very important to have that mindset first, then only you are going to acquire those skills and think like that, right? But engineer කෙනෙක් වගේ හිතන්නේ නැතුව software එක develop කරන්න බැරිය. හරි ඒක එන්න ඉතින් software company software engineers ලා ගන්න නැතුව වෙනව ගන්නේනේ. හරි නම දාලම ගන්න එකනේ engineer කියලා නේද? Right, so that is very important, right? ඔයාගේ academic mindset එකකින් software develop කරන්න බෑ. හරි ඔයාලට පුළුවන් software ගැන කවි ලියන්න පුළුවන්, software ගැන කතන්දර ලියන්න පුළුවන්, but you are not going to do software development, right? Right, coding. So once you have the analyze things, once you have design things, now you want to develop, right? So develop for coding, right? So when it comes to development, so there are a few things, background things you have to understand. Of course, when you are developing, you will be using some programming languages and other computer languages. So therefore, you have to aware of generations of languages. So for example, you must aware of, I am using this kind of a language. For example, if you are doing a web development, PHP project, right? So basically, PHP is a 33GL language, right? HTML and CSS are not programming languages; they have the 4GL nature, right? Declarative nature, right? So likewise, if when you are using SQL, definitely you are using a 4GL language, right? So there you don't specify each and every step; you just say what to do, insert into blah blah blah, select all from. Likewise, but when you are writing Java code or PHP code, you are using a 3GL. You have to specify exactly what is your how to solve the problem, right? So likewise, that is why you have to aware of those things, right? Not for exam, right? Then only you know, okay, now remember when you start writing a project, doing a project, හරි ඔයා එක වෙලාවක HTML එක වැඩ කරනවා, තව වෙලාවක JavaScript validation එකක් කරනවා, තව වෙලාවක CSS එක වැඩ කරනවා, තව වෙලාවක ඒකේ framework එකත් එක්ක වැඩ කරනවා, bootstrap වගේ ඊළඟට back end එකට ගිහිල්ලා database එක හදනවා, තව ටිකකින් PHP වලින් මේ code retrieve කරනවා, හරි. So you have to do all අනිත් පැත්තෙන් සමහරට මේ පැත්තේ framework එකක් use කරනවා Laravel වගේ. So you can see it's going to be complex, right? ඒක මේ කැවුමක් හදනවත් මේ හරි මයෝක දණ්ඩක් හිටවල එනවා ඔක මේ ලංකාවේ මිනිස්සු හරි කැමතිනේ වගාවට නේද? ලංකාවේ මිනිස්සු වගාවට හරි කැමතියි. ඉතින් ඕක කිව්වම මිනිස්සු කියන්නේ මේ වගාවට මේවා කරනවා අරකයි මේකයි කියලා. අරකයි මේකයි නෙමෙයි. දණ්ඩ හිටවල ගන්න කියන එක මහා කජ්ජක් නෙමෙයි. ඒකනේ මිනිස්සු ඔය වැඩි ගණන් ගන්නෙ නැත්තේ. හරි. අර අපේ මිනිස්සු කිව්වට ගොවියා රජ කරන්න ඕන කියලා ඒ ඇවිල්ලා ගොවියුගේ 1800 ගණන් වල. හරි. දැන් ගොවියෝ රජ වෙන්නේ නැහැ. දැන් රජ වෙන්නේ ඔයා දැක්කනේ රජ වෙලා හිටියේ කවුද කියලා නේද? හරි රජ වෙන්නේ engineers software field එකේ ඉන්න අය හරි millionaires ලා billionaires ලා වෙන්නේ. So therefore, but it's not as simple as that. You have to tackle those things, right? So client පැත්තට යන්න ඕන, back end එක වැඩ කරන්න ඕන, database එකත් එක්ක වැඩ කරන්න ඕන. හරි. ඔය Facebook කියන application එක මාක් සකබර්ග් තනියෙන් හැදුවේ. හරි. තනියෙන් හැදුවේ. තව කවුරුත් හිටියේ නෑ ආඩ help එකට. හරි. එයාගේ university එකේ MIT එකේ ඉන්න ගමන් එයා හැදුවේ. ඊළඟට Google company search engine සහ Larry Page දෙන්න එකතු වෙලා එයා garage එකේ පටන් ගත්තේ. හරි. ඒගොල්ලෝ දෙන්න තමයි ඉස්සෙල්ලා හිටියේ engineers දෙන්න. හරි. අනිත් පැත්තේ Microsoft එකේ වුණත් Bill Gates තමයි ඉස්සෙල්ලාම engineer. හරි. එයා manager කෙනෙක් නෙමෙයි. ඒගොල්ලෝ තමයි මේක හැදුවේ OS එක ලියන්න පටන් ගත්තේ. DOS OS එක. So afterwards, yes, now they may not doing lot of development because now they have done that, right? So they know how to get things done also. So likewise, you must know exactly what you are doing, right? So when it comes to coding also, right? Right. So generations of programming language, you have to aware the difference between first and second, second and third, third and fourth, difference between low level and high level, right? So that you have to be aware. So I'm just mentioning. Then different type of computer languages, programming languages, markup languages, styling languages, right? So because if you are doing coding, you have to be aware of those things, right? Big picture. Right? Then features of different programming languages also you have to be aware because you have to pick the correct language, right? Am I going to do it in PHP? Am I going to go for the ASP.NET? Am I going to use Java? Am I going to use C#? Unless you have a very good understanding about the features and facilities each and every language is providing, you are not going to take those decisions. And also if you are not aware of the differences between Java and C#, the way you do Java, you can't just do C#. Right, so you have to adapt to the situation, and also it's a very demanding, right? So one project you are working on Java, so after 1 month, so remember one of my students, I thought that he is still doing some web development. I asked him to do some I asked him can I do a small presentation or session for our final year project students on Laravel. He said no, I am not these yes, I used to work with Laravel about 6 months back, but now I am working on C#. So therefore I am little bit out of touch. I want to look at it, and of course if you really need, I can do it, right? That is the nature, right? So that is how the software engineers work, right? 6 months back working on PHP, now working on C#. In another 6 months he will say, okay, I am now working on new AI related project, right? I am working on Python and I am working on AI project these days. So that is their life is so exciting, right? But of course you have to aware, you can't be a expert, right, of all these things that you can be after about 6 years, 10 years in your career, but you have to at least aware of these things, right? So that is why you are getting some questions from, given a scenario, they will ask what language is best suited for that. Okay, right. Then aspects of coding. So when it comes to coding, there are two aspects: the compute aspects and human aspects. So that is very important, right? සමහර කෝඩ් කරන්න ගියාම හරි අත වෙවුලනවා, හරි ඔයගොල්ලෝ එන්න ඕන ප්‍රොජෙක්ට් ක්ලාස් එකකට එම, හරි අත වෙවුලනවා, හරි සමහරු නිකන් මේක අර කුණු මාළු කෑල්ලක් අල්ලනවා වගේ තමයි කීබෝඩ් එක අල්ලන්නේ, ඇටිටියුඩ් ප්‍රශ්න. එයා ඇවිල්ලා තියෙන්නේ මේ කරුමයකට ඇවිල්ලා වගේ තමයි ඇවිල්ලා තියෙන්නේ. මරන්න ගෙනිනවා වගේ තමයි මේ කෝඩ් කරන්න ඇවිල්ලා තියෙන්නේ. ඉච්ච මරන්න ගෙනිනවා කෝඩ් කරන්නව නේ. මොකටද BID කරේ වට තුනනේ hard disk කරන්න. හරි අපි හිතන් හිටියේ ආසාවට ආවා කියලා, right? So compute aspects are there and also human aspects are there. So compute aspect means when you are writing a code, you have to make sure that it is semantically correct, otherwise you are going to end up with lot of compile errors, right? සමහරුන්ට මුළු දවසේම ගත කරලා තියෙන compile errors fix කරන්න, right? Compile errors නැත්නම් syntax errors fix කරන්න, right? So that is very important. Don't have your syntax errors, right? Of course you may encounter some syntax errors, you must be able to quickly figure it out and also try to minimize your syntax errors, right? Otherwise you are going to spend a lot of time. Then the semantic, so you have to write the correct logic, right? If you don't write the correct logic, there will be a lot of bugs in your system, so it is not doing what it's expected. Then there are some other aspects also, right? When it comes to compute, right? Performance, maintainability, reusability, right? So when it comes to real world software development, when you are writing a code, you have to think about the performance as well. Is it going to take a lot of time? Is there a different way that I can write the code so that it will run faster, right? Is my code maintainable? Should I break this functionality into two methods, or should I break down this into two packages rather than keeping this in the same package? Is it going to help us maintainability? So you have to think about those things. So that is all about real world software development, right? So of course you may not do all those things when you are doing a final year project. Of course you will start doing those things, right? After sometimes you feel like, okay, this package structure is not going to work, I want to subdivide it, but you will do those things if you are aware of those things. So I am not saying that you must be an expert on those things, but at least you must have the awareness of those things, because when it comes to real world software development, otherwise you are going to be a failure. Okay, so I am not going to, I never use the word in the exam you are going to be a failure. I don't mind, right? Because I mind you pass in the exam, but I don't mind you pass in the exams unless you have those skills and competencies and of course the mindset. Okay, right? So that is also important, right? Then the human aspects, right? The human aspects, whenever you write your code, think about yourself and of course your team members, right? If you are writing really bad code, after sometimes you are going to frustrate with your code. Actually it is not you are frustrating with your code or the language, you are going to frustrate with yourself, right? ඔයාට ඔයාව එපා වෙලා, හැබැයි ඔයා ලෝකෙට ගිහිල්ලා කියන්නේ මට Java එපා වෙලා කියලා. ඇත්තට මට Java එපා වෙලා නෙමෙයි, මට ඔයාව එපා වෙලා. හරි, ඔයා ලියන කෝඩ් දැක්කම අපිටත් ඔයාව එපා වෙනවා. කෝඩ් වල තියෙන කැත දැක්කම. හරි, මෙලෝ පිළිවෙලක් නැති කෝඩ් දැක්කම ඉතින් ඔයාට ඔයාව එපා වෙනවා සාධාරණයි. So and also to think about the team members. දැන් ඔයා හිතන්නකෝ ඔයා ලියන කෝඩ් එක කලාතුරකින් ඉන්නේ, ඔයාගේ team member ඔයාගේ ලියන කෝඩ් එක හැමදාම වැඩ කරන්න වෙනවනේ. ටිකක් දවස් ගියාම මිනිහා ඔයාගේ මූණ බලන්නේ නැහැ. ඔයාගේ team members ට. ඇයි? ඔයා ලියන කෝඩ් එක වැඩ කරලා මිනිහට ඔයාව එපා වෙලා. හරි? එහෙම කරන්න බෑ. එහෙම කරන්න බෑ. වැඩි දවසක් ඉන්න හම්බ වෙන්නේ නැහැ. හරි? ඔයා ෆෝන් කරනවා ඉතින් team members ට. හරි? කොහොමද කියලාම ඔහේ ඉන්නවා කියලා මාරු වෙනවා. කතා කරන්නත් කැමති නැහැ. මොකද මතකයි අද උදේ මේක ලියපු කෝඩ් එකක් අරගෙන මම කෝඩ් එක තනිකර සුද්ධ කරා කියලා මතක් වෙනවා මිනිහට. හරි? So think about those things. If not about yourself, at least think about others. Right. So there are some best practices when it comes to what they are technical දේවල් කතා කරන්නේ නැහැ. ඔයා engineering mindset එක හදන්නේ, right? So there are some best practices. Follow the coding standards, right? So like naming conventions, documenting standards, follow those things, because otherwise things are going to be really messy. Comments where add values, right? So if you are writing very complex logic, have some comments, right? Not right, this is going to be system outcome, println is going to print something, ඒ වගේ බයිලන්න ලියන්න එපා. හරි, obvious level you don't need, but if it is a really complex things, complicated things, so have some documentation there, right? Proper indentation, and also come up with the simple solutions, right? So the simplest solution that does the work is the best solution. So a lot of Sri Lankan people do engineering, right? So one of the biggest issue in engineering field in Sri Lanka, engineering field කියන එක එච්චර දියුණු නොවෙන්න හේතුවක් තමයි ලංකාවේ engineersලා engineering කරනවා. ඒක ඇවිල්ලා අපේ culture එකෙන් ආපු දෙයක්. අපේ ශ්‍රී ලංකාවේ තියෙන culture එක තමයි මොනවාද? engineering. engineering. හරි. අපේ ඇඳුමක් ගත්තත් engineering. හරි. ඔයගොල්ලෝ දැකලා ඉන්නේ නේද? අපේ මිනිස්සු ඔෆිස් එකට යනකොට විශේෂයෙන් කාන්තා පාර්ශවයේ සාරිය ඇඳලා රැලි තියලා කටු ගහලා ඔළුවේ මල් ගහගෙන තමයි යන්නේ. ඔය වගේ ඇමරිකාවේ වගේ යුරෝපේ රටක මිනිස්සු වැඩට එන්නේ කොහමද? බ්ලවුස් ඇන්ඩ් ස්කර්ට් එක ඇඳගත්ත නැත්නම් හරි ඇඳගත්ත ඒක සරල වෙනවා. අර මිනිස්සයාට ගිහිල්ලා වැඩක් කරන්න පුළුවන්ද? නෑ වැඩක් කරන්න බෑ. යා සාරියේ මේවා හදනවා හරි ඔළුව හදනවා. එතන ඉඳලා engineering. හරි තමන්ගේ ඇඳුම් පැළඳුමේ ඉඳලා engineering. හරි කෑමක් කිව්වමත් එහෙම නෑ. අපි තරම් engineer කරලා කෑම හදන මිනිස්සු ලෝකෙ කොහෙවත් නෑ. ඒ කියන්නේ අපේ මිනිස්සුන්ගේ අපේ ලංකාවේ ඉන්නවනේ කට්ටිය ගෘහණියෝ කියලා නේද? ඒගොල්ලන්ගේ ජීවිතේ මොකද්ද? කෑම උයන්නේ. අනිත් මිනිස්සු වැඩ කරනවා වෙන වැඩ කරනවා ඒ ටක් ගාලා මොනවාද දෙකක් හදාගෙන කනවා. හරි සරල විදියට. So that is engineering. So don't do that. When it comes software development, if your solution is engineering, මොකද ඔය මල් ගහන අර හොල්මන් කරන එක්කෙනා තමයි ගිහලා කෝඩ් ලියන්නේ. ඒ පාරේ කෝඩ් එක ඇතුලේ අර තියෙන ඔක්කොම හොල්මන් වැඩ ටික කරලා තියෙන්නේ. එක්කොට ඒක සිම්පල් සොලියුෂන් එකක්ද? නෑ. මොකද එතන හිතන්න එපා නෑ මම ඇඳුම් එහෙම වුණාට මගේ වැඩ එහෙම නෑ කියලා. නෑ ඔයාගේ ඇඳුම්මයි පැළඳුම ඒකනේ software ඔයගොල්ලෝ දන්නවනේ software development company එකට ගිහිල්ලා බලන්න. එතන ඉන්න ඔක්කොම වගේ ඩෙනිමයි ටී-ෂර්ට් එක ගහපු අය තමයි ඉන්නේ. හරි ඩෙනිමයි ටී-ෂර්ට් එක ගහපු අය තමයි ඉන්නේ. එතන නෑ සාරිය ඇඳලා කටු ගහලා ආපු කට්ටිය නෑ. හරි. ඇයි එයාගේ මයින්ඩ්සෙට් එක හදන්න ඕනේ මේ සරල සොලියුෂන්ස් වලට දෙන්න ඕනේ කියලා. හරි. අනිත් අය ගොඩක් software engineering companies වල දවල්ට කෑම දෙනවා. හවස් වෙනකන් හිටියොත් රැයට කෑම දෙනවා. ඇයි ඔයාව අයින් කරනවා මේ අනිත් දේවල් වලින්. හරි. ඔයා කන්සන්ට්‍රේට් කරන්න. ඔය අනම්මනම් උටපට වලට ඔයා හිතන්න එපා ගෙදර අද උයන්නේ මොනවාද? හරි. උයනවා කියන එක ඕන මිනිස්සෙට කරන්න පුළුවන්. ඔයාව අපි ගත්ත ඊට වැඩි ලොකු වැඩ කරන්න. හරි. ඊට වැඩි ඇඩ්වාන්ස් වැඩ කරන්න. මිනිස්සුන්ට හැන්ඩල් කරන්න බැරි දේවල් කරන්න. හරි. So you concentrate to, but make sure your solutions are really simple, right? So really complex problem, but genius people come up with really simple solutions, right? So that is the beauty of the good engineers, right? Good engineers, right? So it's not. So I hope you have heard Einstein quotes, right? Einstein කියලා දෙනවා මොකද්ද? Any fool can make things bigger and complicated. It's touch of genius who make things simpler, right? So that is Einstein, right? Einstein complex දේවල් හිතපු කෙනෙක් නේද? But any fool can make things bigger and complex, right? Any fool. Only ඔයගොල්ලෝ දන්න ලංකාවේ ඉන්නවා මේ දේශපාලකයෙක්. මිනිහා ඉංග්‍රීසි කතා කරද්දී ලෝකේ තියෙන අමාරුම ඉංග්‍රීසි වචන කතා කරන්නේ. ඒකට අපි ඉංග්‍රීසි කතා කරනකොටම අපි දන්නවා මිනිහා හරකෙක් කියලා. ඇයි හරක් තමයි any fool can make things complicated, right? So only simple විදියට යමක් ප්‍රසන්ට් කරන්න පුත්තිලා තමයි හරි ඊට අමතරව අපිට සරල ජනාධිපති කෙනෙකුත් හිටියා. ඒ ඇවිල්ලා ඒ මනුස්සයාගේ තියෙන සරලකම නෙමෙයි. ඒ මනුස්සයාට කම්ප්ලෙක්සිටි හැන්ඩල් කරගන්න බැරි සරලකම. හරි සරලකම අයින්නේ අපි වැඩ කරන විදිය. හරි ඇඳුම්ෙන් පෙරදුමෙන් බෝල් පොයින්ට් පෑනෙන් ලියන එකකින් කියන එක නෙමෙයි. හරි වැඩ කරන විදියත් එක්ක ඇඳුමට ආවට හරි. Right. So then the importance of code review. Now still we are in the development of the coding. It's very important to do the code reviews in your software development team environment. Right, team environment. There are a lot of benefits, right? Of course, it will identify and fix possible issues early, right? You are not waiting until, so 1 minute, yes. So we are not waiting until the last moment to find the bugs. At code level on itself, we are fixing issues. Then it enforces follow coding standards. When someone is reviewing your code, he can pick if there are any coding standard violations and ask you to fix those things. And also it helps learn from each other, right? So when I review your code, I help you, I point out some issues in your code, then you can learn from me, right? Because sometimes you are blind to your problems, and also if you are a junior programmer, you are not aware of that particular problem, right? Sometimes the other senior developer is aware of that. He will review your code and find out that issue and help you. Then you become very matured person very quickly, right? Very matured person. In software development, we are not measuring your experience in years. We measure your experience on how much of work you have done, how much of a different projects you have worked on. So that is how you measure, right? So it's government sector that measure by years, right? So in private sector, how much of work you have done, how much of exposure you have. So that maturity you can quickly get by help of your other team members, right? And also there's a psychological effect of quality consciousness. When someone is going to review your code, you don't want to write a bad code, right? Because you know that my friend is going to review my code. So that is psychological effect. That is good, right? So then there are two type of code reviews, what is known as lead review and peer review. Right? Lead review means a senior member will review your code like a tech lead or architect. Peer reviews means if you are an engineer, your fellow engineer is going to review your code, you are going to review his code, or you are going to review someone else's code. So those are important. So lead reviews, if it is possible, it is always good, but a lot of times leader can't review all of the others code. Therefore, sometimes you want to go for peer reviews as well. So actual peer reviews will increase your team binding also, because you are helping your fellow team members, right? Remember, it is not finding faults. Some people take it as a negative thing also. Code review is not about finding faults, not at all, right? Code review මේ කාගේ හරි දින වැරදි හොයන එක නෙමෙයි, right? සමහරව එහෙම නේද? අල්ලපු විදිහට වැරදි හොයනවා. රිවිව් කරනවා කියලා මම අරයා කෝඩ් එක වැරදි වෙන්නේ නැහැ. So I am just going to help him, right? I am just going to help him. I am just going to help him finding its issues, right? So because he is also going to help me, right? So that is the mindset of reviewing, okay? Right, so reviews can be done in two ways. So the normal code review and code walkthrough. In code walkthrough, the person who have written the code is going to explain the code to the reviewer. Then the reviewer can give the feedback, right? So in other normal review, you just share the code with the other person. He is just going to review by own, right? So those are the two different approaches. There are pros and cons that I am not going to discuss right now. Right, so the final topic we are going to discuss today is testing. Right, so analyze, design, develop, then we have to do the testing. As I told you, engineers never release something without proper testing, thorough testing, right? So they want to make sure that your product is bug free. And also we discussed that one of the issues in modern software development is a lot of bugs are still there in the software. We don't want that to happen, right? Because of the immaturity in the technologies and stuff like that, we had that issue, but now we are going to rectifying it. A lot of now products are really stable, right? A lot of products are now really stable, right? So about 10 years back, right? Not about 10 years back, about 15 years back, when we are working in the Windows environment, we always get that blue screen, right? So at least about 3 months, every 2 months, 3 months, we get the blue screen, and some frequently every 3-4 months we get the operating system corrupted, right? So therefore we always back up. Sometimes every day, right? Sometimes not every day. About every 3 hours we back up our work, because our systems are really unstable. But now things are really getting stable. Why? We do a lot of testing. Not only testing, right? Testing is just part of it. Your next topic is quality assurance, that we are not going to cover here. Quality assurance is the big picture. Testing is just part of it. But anyway, we are going to discuss only about testing here. Testing is, if there are any issues in your product, we detect it by ourselves before it goes to the customer. Because when we detect it by ourselves early, we can make sure that we are releasing a bug-free, issue-free, fault-free software to the customer. That customer is going to really like it, right? Right. So first we have to understand the difference between verification and validation. Verification means, are we building the product right? So that checking of are we building the product right is verification. Validation is, are we building the right product, right? Are we building the right product? So basically the code reviews and design reviews are done for verification, right? So are we building the product right? අපි හරි විදිහටද මේ product එක හදන්නේ? ඒක තමයි review කරලා බලන්නේ code එක. Code එක review කරලා බලනකොට අපිට අහුවෙනවා නෑ ඔයා coding standard follow කරලා නෑ. ඔයා මෙතන එච්චර හොඳ විදියට නෙමෙයි මේ loop එක ලියලා තියෙන්නේ. මේ method එක දෙකට කඩන්න තියුණා. And are we building the product right? අපි හරි විදියටද මේ product එක හදාගෙන යන්නේ. right? ඒක තමයි මේ reviews කරන්නේ. But validation is, are we building the right product? අපි මේ හරි product එකද හදන්නේ. ඒකට අපි test කරලා බලන්න ඕන හරියට වැඩේ වෙනවද කියලා. right? So those are very important. Both are important, right? Not only just one. Having both will give you a very high quality product, right? High quality product to the customer, right? Right. So we are only concentrating about the reviews we discussed in the previous development stage. Now we are only going to discuss about the validation, that is, are we building the right product? So how to do that? Do a lot of testing, right? Do a lot of testing. So actually there are a lot of type of testing, starting from unit testing, integration testing, system testing, user acceptance testing, and there are some other testings like performance testing, load testing, usability testing, regression or smoke testing. So you must aware of each and every type of test, because if you go to industry, before a product released to the customer, all of these type of testings are done. All of these types of testings are done, right? Then only it is going to be released to the customer, right? So it depends, right? So you don't do load testing very frequently if you are just doing a small changes here. But overall, yes, we have to do those kind of testing. Okay, right? So let's take one by one. Right, so before taking one by one, let's discuss the testing life cycle also. Right, so testing, there are two things: writing the test case, executing the test case. Right, so those are two things: test case writing, executing the test case. So that is why you have the QA engineers separately, because they have to spend a lot of time writing test case also. Right, the moment you get the requirements, you can write the acceptance testing and system testing. Right, so that is not executing. While the requirements are gathered and when the requirements are stable, you can write the acceptance testing and system testing, right? While the designing is done, you can start writing the integration testing and unit testing, right? Of course, then you develop it. Then, so we can see first we write these tests, we come like this. But when it comes to execution we go like this. First we write the acceptance test, then system test, then the integration test, finally the unit test. But when it comes to execution, first we execute the unit test, then the integration test, then the system test. Of course, finally we execute the acceptance test. We didn't take the other special type of testing here, right? That is how it works. So you must have that big picture, right? How the things are really work in the real software development environment, right? In real software development companies, right? So that is very important. Right, then we can categorize testing into two: black box testing and white box testing. So black box testing means we think of the system as a black box without awareness of how the really the design and coding is done. We test whether for the correct input we are getting the correct output, or whether we are getting the correct functionality. So that is called black box testing. System testing, user acceptance testing, those kind of testings are black box testing. So white box testing means aware in this how the internally the packages are structured, the logic control structures. We want to test particular scenarios, whether just to test whether test whether those logics are correct. So that is called white box. So better term is better term is actually glass box, because it's something like glass. We are aware of what is happening in the inside. So that is the main testing for that is unit testing. Unit testing is the main testing that every developer is doing, and integration testing. So those are integration testing, unit testing, interface testing. Those are white box or the glass box testing. Okay. So mostly glass box testing is done by developer, because the developer is the one who knows the internally how the things are happening. The black box testings are mostly done by either quality assurance engineers or the customers, right? So that is so that big picture is very important. Just aware in මේකයි කියලා හරියන්නේ නැහැ. මොකද්ද මේ දෙකේ තියෙන වෙනස? කවුද මේවා කරන්නේ? ඇයි මෙහෙම කරන්නේ? අන්න ඒකට ස්ටඩි කරනවා කියන්නේ. අන්න ඒක අරගත්ත කට්ටිය තමයි ඉන්ජිනියර්ස්ලා වෙන්නේ. හරි. අනිත් කට්ටිය උපාධිධාරී. හරි. උපාධිධාරී ඉංජිනේර කෙනෙක් වෙන්න කැමති නම් දෙකම කරගන්න. Right? Okay. So unit testing. So I am not going to go through each and every one. So unit testing means basically testing individual units. Right? Testing individual units, whether that unit can be a class, that unit can be a module. Right? So you test whether that is working. So that is very technical thing. So you see that the developer is going to do that. Right? Unit testing. And it's also glass box testing. Right? Done by developers. And also there are a lot of testing frameworks. If you are a Java developer, there is something called JUnit. So those things you can write it's basically the unit test case is also Java code if it is Java, right? And you can integrate it to your build or the IDE and you can run it, right? Part of the build. First it will build and see whether there are no compile errors. Then it is going to run all your unit test cases to whether it's pass or fail, right? So assume that yesterday all the test cases were passed. Today you did some changes. Now when you build, two of the test cases are failing. That means because of that change, some of your functionalities has broken. So you can early detect that. That is why you need a unit test, right? And you want to integrate it with the main build also, or your IDE also. Okay, so that is the normal thing in software development, right? If you go to a software development company and start working on that. They will give you the code base. It will definitely going to have some unit test cases also. And when you build, first it will build the code, then it is going to run the unit test cases and say, okay, it is no compile errors. There are 250 unit test cases and 245 is passed. 5 are failing. Then you have to figure it out why 5 of them are failed. And then your tech lead might say, okay, there are some issues with the build right now. Forget about those 5 failures, but make sure those failures are not getting increased, but due to your changes, right? So likewise, there is a communication. So that is why all the team members are in the same environment. Okay, right? So that is unit testing, and that is heavily done by developers, and it's a white box. Then we have the integration testing. That is, now we want to integrate, we test whether those modules are properly getting integrated. So that is called integration tested. It is again white box testing and done by developers, because developers are the people who are going to integrate those components together. Okay. Then we have the system testing. That is the big testing done by the QA people. Of course, the developers also will do initial system testing. So that is where we check whether our different usage scenarios are properly functioning, right? So can I add a customer? Can I add a order? Can I cancel an order? Can I do a payment properly? So likewise, of course, initially the developers are going to do the unit system testing. Then once you do a release to the QA people, right? QA release, the QA people are quality assurance engineers are going to do heavy system testing, right? Heavy system testing they are going to do. Okay, so they are going to testing different various scenarios to see whether it's working. Okay, so that is system testing. Then once the system testing is stable and there are no bugs, or there are only few trivial bugs that is not going to affect your customer, then you give it to the customer, right? Of course, it can be released, right? In Agile, actually, we frequently give that kind of releases every four weeks, right? Every 4 to 5 weeks. Then user is going to test it and see whether it's working fine for them. So that is called user acceptance testing, right? It's again a black box testing. And if the user is happy, he is going to accept the release. If the user is not happy, he will ask to do those changes and again come back to him. Or if he is really not happy, he is going to discontinue work with you, right? Discontinue work with you because he is not happy about your feature application. Okay. Then we can have the performance testing also. That is test whether the performance is good. That means the response time of a screen is good. That means sometimes the user may have a requirement saying, okay, when you do this particular search, I need the results in the screen within 5 seconds, right? 5 seconds. So we can just test and see whether you are getting the results within 5 seconds. So that is called performance testing. Then there are some other things like memory usages, etc., right? Special case of performance testing is load testing, where you apply a load and test. For example, if it is a banking application, right? Pretty sure your application, your web application is going to be used in a particular second, at a particular moment, at least 1,000 people, right? And මේ වෙලාවේ ඔයගොල්ලෝ හිතන සම්පත් බැංකුවේ ATM machines උයි ඒ ඔක්කොමත් එක්ක සිස්ටම් එක එක වෙලාවක මේ මොහොතේ 10 ගාණක් ඇක්සස් කරනවා. ඉතින් ඔයා software develop කරද්දී එක්කෙනෙක් විතරක් ටෙස්ට් කරලා ඉවරලා දැම්මට පස්සේ ටෙස්ට් කරන්න බෑනේ. So you have to test that, right? 10 ගාණක් එකට මේක ඇක්සස් කරද්දී මොකද වෙන්නේ කියලා ටෙස්ට් කරලා තමයි ප්‍රොඩක්ට් එක බැංකුවට දෙන්න ඕනේ. හරි? මොකද 10 ගාණක් ආවට පස්සේ මේක සිස්ටම් එක හැංග් වුණොත් එමෙ හරි? So we have to test that. So that every software development company, if you are doing that kind of projects, right, they have that load testing teams, right? Load testing teams, they have a lot of tools for that. හරි? අපි 1000ක් එකතු කරන් ඇවිල්ලා ටෙස්ට් කරන්න බෑනේ නේද? 1000ක් එකතු කරන් ඇවිල්ලා ඔන්න දැන් 1000 මේක සිස්ටම් එකට ලොග් වෙන්න කියලා නෑ. අපිට එච්චර මිනිස්සු ගන්න එන්න බෑනේ. So there are tools, load testing tools, they will apply the load, right? So you have to program those scenarios. ඒකට testing කරන්නට programming අපි උගන්වන්නේ. ඒගොල්ලෝ test program කරන්න උගන්වනවා. පුළුවන් ඒගොල්ලන්ට. හරි? ඒ වෙච්ච අමාරු දේවල් නෙමෙයි. හරි? software development තරම අමාරු වැඩ නෙමෙයි. ඒවයි තමයි ලේසි වැඩ. අන්න එහෙම කළා ටෙස්ට් එක කළා ඉතින් අපි රිසල්ට් එක දෙනවා. හරි? concurrent users 1000ක් access කරාම මේ page එක log වෙන්න තප්පර එක user කෙනෙක්ට average මෙච්චර වෙලාවක් ගියා. හරි? worst case එකේ එක්කෙනෙක්ට තප්පර 20ක් ගියා. හරි? happy best case එකේ තප්පරෙන් log වෙච්ච අයත් හිටියා. අන්න එහෙමත් මේක results දෙනවා. tool එකෙන් දෙන්නේ. tool එකෙන් දෙන්නේ. මොකද load testing කරන්න බෑ අපිට. හරි? එහෙම කරන්නවත් 1000ක් විතර එක යාළුවෝ ටික එකතු කරන් ඉන්නවා ටෙස්ට් කරන්න. That is not practical, right? So that is called load testing. Then we can have the usability testing, or that is test whether it's a user friendly. So that you have learned in your user interface design subject. Okay, usability testing. So I'm not going to discuss that. Then you can have the regression testing. So regression testing is, we now assume that we have released the product to the customer. Again, customer asks us to do some changes. Once we do the change, we can't just test the change only. We again have to do the overall testing. So that overall testing done again is called regression testing or smoke testing. Of course, we may not test everything again because it's a lot of effort. At least we may pick some scenarios which is going to related to our change, and again we are going to test it again. So that testing is called regression testing, just to check the health of the system again, because we did some changes. හරි ඒක හරියට ඔපරේෂන් එකක් කරාට පස්සේ ආව පොඩ්ඩක් ඉස්පිරිතාලේ නවත්තන් ඉන්නවා. මොකද ඔපරේෂන් එක කරේ එක තැනක වෙන්න පුළුවන්. නමුත් මේක ඉෆෙක්ට් එකෙන් වෙන වෙන තැන් වලට වෙන වෙන ප්‍රශ්න එන්න පුළුවන් නේ. ඒක හන්දා ආයිමත් පොඩ්ඩක් ටෙස්ට් කරලා උණ බලලා එහෙම කළා තමයි යවන්නේ. Same thing, that is called regression testing or smoke testing. හරියට නිකන් දුම් ගහලා බලනවා වගේ. හරි. Right. Then we have the alpha testing and beta testing. Alpha testing means you are giving it to the end users, not a user acceptance testing. You give them to the end users and ask them to use it casually, not for serious things, just to see whether they are happy with it, and also it help us to identify if there are any possible issues. Right. That is called alpha testing. If you go for a software sites also, sometimes you can download the alpha version and use it. But that is usually you don't do it unless you really like to learn the new thing or something. But it helps them also. Because if you encounter any issues, automatically those results will be sent to them. So beta testing means the next stage, when things are even more stable, we do a beta release. So beta release means the issues in the alpha release is identified, those and fixed. But still, that is not your main release, right? Still, there might be some issues, but you feel like this is fairly stable, right? So this is sort of a candidate for a future release in near future. So that is called beta testing. Again, it is done by the user, right? So that is how it goes, right? That is how it goes. So that is all about testing. So I try to cover everything, but I was more interested about the first half of my session. I give you the understanding about the big picture of software, right? Software project, engineering, and the importance of management, then how to put those things together. Of course, we were more interested about the engineering, because project management we are going to discuss in a separate topic. So in another session, I am going to cover the next 3 topics, which will take about only half an hour, 45 minutes. Then do some past paper question in the next session. Okay, so thank you.